All right. Let's see what we're up to here. Hey, there's Pessa. How you doing, man? You've probably seen our relative success over on YouTube, and we're just kind of hanging out and talking shop and doing a little more of the, this same stuff we've been doing the whole time. Yeah, you coming over next weekend, Pessa? Or 2 weekends now, I think. Yeah, we're going to try to keep it going and then get ready for summer. Any of you guys out here in Phoenix, man, it's a hot one coming up. Super busy with the WGUCS degree. Nice, Pessa. Yeah, I know there's a few people in the Discord working on that, so that's pretty cool. Yeah. And Pessa, you've been over before for the drift trike, so I'll have drift trike videos for people in the Discord later. All right, so let's do this a little bit. We're going to talk Linux system administration. Almost everything I've been doing the last few days has been all hands-on. And we're big fans of hands-on around here. It's a useful way to do things. I think you should get a lot of hands on the systems and stuff. But today's going to be a little more theory. And I will also be pulling, well, there will still be practical application, but I'll also be pulling up the different systems we have here. The other day, somebody asked me to do a deployment, so I pulled that up. And, I have the screens, and we can do some Linux as we need. But mostly we're going to talk about Linux system administration. What do we do as systems administrators? What do we need to know? All of that kind of stuff. This is a lot of the, getting the job. Yeah, Mariano, double stream day. Yeah, I don't normally stream on Saturdays at all. But the wife is, she had some friends over, and they're watching some girl movie. It's a bunch of girls. So I am hiding upstairs in my office, which is like my little bell tower. Like I'm Quasimodo hiding away from everybody. So, yeah, I'm kind of hiding today. We had really good Indian food from a place down the street that's the best Indian I've ever had in my life. So, best Indian food anyways. So, all right, so let's do this. Let's talk about some of the administrative tasks that you do as a Linux systems administrator. Like, what do we do? We have a lab portion that we do, and you guys have been hitting the labs the last few days. Anybody that's been around, anybody that's down the Discord, labs are in all these other videos. We're always talking about all the labs out on Killer Coda. But during the lab portion, you can learn to perform many of the tasks. But mainly the things that we do is we power on and off servers. We verify what servers are up of our inventory. We maintain inventories of servers. So right here, maintain inventory of a system, add, change, remove inventory, deploy servers in the same fashion that we deployed other servers. It's a skill in of itself, is to make sure that all your servers are exactly the same, right? Installing and updating software. Sometimes we have servers that are stateful, and we patch them and update them, and they move forward with us for years and years before they go away. And sometimes we have stateless machines that we just turn off and bring back up. And depending on how kind of data center-y and how cloud-y your systems are, so how much in the data center or how much out in the cloud you are, is going to determine kind of what you're doing with that. But for those of us that run stateful type systems where we patch and update and stuff, we have to configure repositories, and we have to make sure that the software works within the cluster and keep everything at a certain baseline. So for me, I like to run a lot of things in tables. I run a lot of tables either in like a OneNote, or I will use Excel if somebody needs me to. I can also build CSV files inside of VI if I need to. But the point is I keep stateful how my system is looking in a way that I can present to other people quickly. You might say, I just throw it in a database. Yeah, I could do that. But also I need it to be in a manner that's really easy to show to others, because a lot of times in administration world, we're interfacing with our business counterparts. So we got to update software. And then another big part of it is responding to incidents. Tickets are going to come in. Things are going to break. We've got system level failures. We've got security incidents. Both of these things we talk about in other presentations, so we go more in depth on those. But this section focuses on the other types of tasks that an administrator will find themselves doing within a group, okay? Or within a group of systems. So we're going to talk a lot about just things you're going to find yourself doing as a systems admin, right? So here's some things that you're going to do. There's 4 major parts of a system, I guess, a Linux system. There's 4 major things. There's other things. There's a lot of other things. But there's 4 major ones. They are the CPU, the memory, the disk, and the network. Those are the things that get used up. Those are the things that get saturation to them. So what we want to do is we want to know how to observe them, how to see what's going on, how to, verify that we have enough, right, in some cases. Maybe we want to observe them and track them in the historical sense of what's going on. And then we use tools to feed that out to like time series databases. And then we look at it in Grafana and we say, yeah, we can observe that the system is being used at some part. How can you load test? So load testing, Malvi, is there's a couple of ways to load test a system if you're talking about actually load testing. So there's stress. Stress will just set normal load of just a generic type to a system. You can also do, there's tools like, there's a tool called K6 will do web server testing. You can also use Burp for stuff like that. You can load test your systems just by spinning up high CPU memory or disk by knowing how to utilize those. So I have some labs where we spin up the different resources just to see what happens. So you might have a service running, and then you may just spin up the CPU to see what happens when the system's under load. There's two general things that we want to know about a system. In general, there's two things that we want to know about, like a software or service or a computer system or anything, and that is it fit for use and is it fit for warranty? This comes from a different talk of mine, but I'll talk about it for a second. The fit for use is, does it do what we think it's going to do? Does it check the box? So let's say we're running a web server. Fit for use would be, is it on port 80? Yes, check. Is it serving the right page from a document root directory that is secured in some way? Check, right? And it's all these things that we can check. The fit for warranty, which is the other part. Fit for use is, does it do what it says it does? Fit for warranty is, does it do it as often as it says? Fit for warranty would kind of be like how it operates in the wild. And that's the idea, something like this that says, well, what if, what happens when the 5,000th and first? So 5,000 people can run on the server, but what if the 5,001st person shows up? Does it still show that web page, or does it spin? Or does it give them a 404 error? Or does it give, what happens when the server is actually out there rolling down the street doing what it's supposed to do? Does it do it as often as it needs to? And there's different ways to load test depending on what your system is. But those are the two things basically that we check. Is the system able to do all the things we expect it to do? Does it check all the boxes? And then the other part of it, turn that a little bit, check all the boxes. And then the other part is, does it do it as often as we need to? Where's Grafana lab products mostly used by the industry, and which ones do you use mainly? Malvi, I mostly use the Grafana tool. I just use Grafana to show everything. There are other tools out there that Grafana has that are also useful. I guess Prometheus is owned by them too, so that's a big one as well. Well, I gotta change this music. It's too loud. I don't know why some of these come through so loud. All right. But yeah, we observe things, then we benchmark them so we can load test. And again, we don't load test on production systems a lot of times. Benchmarking will get its own section. Benchmarking is kind of, there's two things. There's benchmarks and there's baselines. So baselines are the lower one of the two. Baselines are, how does the system just operate throughout the day? And from baselines, we get things like high water marks and all this kind of stuff about the system. But benchmarking tends to be when we actually push the system and see what we're able to get out of the system. So people use benchmark and baseline interchangeably, but I like to think of baseline as, that's all my, how my system's operating. On Fridays, maybe my system goes to a little bit higher load because of the fact that we get a lot of gamers or something on it. And then that's just a normal operations benchmark type thing, right? We have this in my home lab here. Do I have just something like this where over time I can go look for the last 7 days here and see what's been going on in my systems? And I can go look at anything that I need to around memory usage or CPU usage of machines that I care about in my home lab, right? This is a thing that's kind of common. You guys can see my network storage and my root storage on some of my servers to see how much used they are, right? And that's something that I like to see. Is Grafana tool more popular than Prometheus? So they serve different purposes. Prometheus is a time series database. Prometheus tends to be a middle piece, and then Grafana tends to be an end piece that we use to share and alert and show data later. Prometheus is not optimized for showing to other people and giving other people access like Grafana is. So something to think about there. All right. And then the last thing we do, we actually make changes, right? We change the system. So we observe, we can load test, we can change the system. And you got to understand, where your changes should occur. You should do changes in a lower environment and test them and verify that they behave the way that you want and have a rollback plan and those kind of things before you go push them up into a production environment. Prometheus is mainly for string and metrics, and Grafana is for showing it. That's fair. Yeah, so Prometheus stores information in a time series database. Yeah, anything that it scrapes. And remember, Prometheus is always out there polling data, Polling. I actually have a lab on Prometheus. If anybody wants the lab, it is right here. I actually had it up because I was thinking of doing some stuff with it potentially, so we could possibly do this lab. Here's Prometheus lab on the Twitch side. I'll just pin it for the night, and then we'll pull it off if we need to, and then I'll dump it over on the other side as well, on the YouTube side, for anybody that wants it over there as well, so you guys have it. So that's the lab that we could potentially work on a little bit tonight if we want to see some of this stuff. Like if you guys are like, well, I want to get my hands on it. We've done this lab in other senses, so we could do that anytime. Data received on Prometheus is visualized with Grafana. That's typically what we do, Sandeep, yes. We will typically send data over. In my home lab, it looks like this. So this is what it looks like in my home. That was us messing around earlier. Don't save that. And let me just open. I'll show you guys what it looks like in my home lab real quick. Monitoring. This is the ProLug home lab setup for all of my systems, right? And this isn't exactly what we're doing right now, but this is important as we talk about systems. We've got Grafana at the end over here. Grafana is the last piece. We have things that are feeding data into InfluxDB. We're pushing data. We have things that are pushing data into Loki as an API endpoint. And then Prometheus is querying every 10 seconds. It's doing polling. Hey, do you got data for me? Hey, do you got data for me? From node exporter. So this is actually considered a scrape. Prometheus does a polling. It scrapes data off of node exporter. Loki is an API endpoint that you can write log data to, Malvi. So Loki, I actually have a lab that does each of these pieces here. So there's a lab that shows you how to send data into Loki and then read it out. What it looks like in the home lab, I'll show you guys what it looks like in my home lab here. It looks like this. So these are all the logs coming in. These are all the failed from secure. Anything failed. So these are all the people in the last 6 hours that have tried to log into my home lab and gotten themselves failed out forever through failed to ban. These are all the users and their IP addresses and all the BS users. Somebody tried to come in as Pi and Postgres. And we almost always have, I haven't seen it lately, but we always have ES because that's Elasticsearch, right? Postgres again. ES right there. There's an ES. Remember I told you guys that we'll almost always have an ES, and this is where it came from, and this is the IP address and all that kind of information right there. So this is what Loki does, is it feeds that data over, and then you can query it out with Grafana. And in this case, I just want to see in the last 6 hours who's failed. And then over here, this is my security. This is how many people every minute have failed out of my system. And these are the 38,000 that have failed themselves out forever over here, right? And we actually have all that captured and mapped for people that wanted to see like a map over the whole globe. I've shown that before on stream. But anyway, so we're getting kind of far afield, but observe, benchmark, and tune. These are very important around what we do as a systems administrator. I need to know what's safe for me to do at any time. I need to know what's actually spinning up my system, and then I need to understand when I'm changing things and when I shouldn't do that. Hey, Suresh, how's it going? We are going through the Linux systems administration and just kind of going. I do not have Elastic Stack in my home lab, Joseph. No, unfortunately, no. What I do have in my home lab is all of these other pieces, though. And one of the things I'm going to be doing, I decided to do this the other day because I have a tool that nobody's really using right now, and I would like more people to use, so I'm going to start pushing this up into the Discord more often. But we have a tool here called... if you guys have never seen Guacamole, we have... shoot, where is it? I need to find it. Oasiscom.com. I need the specific port number which I think is 34001. Is that right? No. I have to find the lab. I don't remember exactly where I have it. But anyways, you guys can get in, and then I'm going to start pushing it out every day so that you guys can get access. There's Ranger Cam. Ranger Cam's up. All right. So we'll get that going. That's going to be coming. And HTML5 alternative to RDP VNC. Yeah, I actually really like my low Guacamole setup, and it gives all of you guys access to get into the servers, and then you guys can do stuff. And then as long as that is reasonably used by people like adults, then we'll just keep doing it. And I'll just send out the data of usage to everybody in the Discord so people can see how much is being used and that kind of stuff. What happened? Sorry, noob. How do we build this dashboard? Amai and Galahab over on the, or Galab over on the YouTube side, we have all the labs to build that dashboard I just showed. Unfortunately, I'm not going through them right now, but they're in my lab stuff. It's all the monitoring stuff. There's 3 labs teach you how to build all that. Okay. Anyways, when we go to look at a system, this is kind of an important thing. I like to kind of draw this out for you guys a little bit. So when we look at a system, there are 3 things to check. This is called the use method. U-S-E, use. And what happens is utilization is between 0% all the way up to 100% of a system. So when we start looking at some of these commands and talking about this, you're going to see 0% utilization of a system, maybe like 60% utilization, right? So you got some 60% here of the system, and all the way up to 100%. Once we get to 100%, so this is always 0 to 100, percentage of a thing. Then we get to saturation, and saturation is a Q. Saturation is when we have to start forming a line to wait, right? So now we've got a line to wait for this resource of some type. So the resource is sitting here between 0 and 100%. Once we get to 100%, now we're waiting, and there's starting to be a line, right? We're getting a line for wait, and then we hit a wall of timeouts, and timeouts are where errors happen. I think I have that mentioned down here, right? Yeah, so as we look at some of these things, we're going to be looking at utilization, how much of a system is used. Then if we hit 100%, now we start to have this line where we're waiting for things. Whatever it is, if it's those big 4, CPU, memory, storage, network, we're waiting for things. We start to hit timeouts and errors start to happen. Errors are much more insidious when they're coming other systems waiting to get into our network or something like that. But we can look at all this, right? We can figure this stuff out, and we have to know how to use our tools to do it. So I really like the use method when I'm showing people how to look at systems, because it's utilization of the system, saturation of the system, and then errors and logs and those kind of things, okay? So what are we looking at? How are we breaking this stuff down? Hey, B-Bison, thanks for the follow. Hopefully this stuff's useful to you. I'm trying to log in as different users for services running. Yeah. And then Mariano, we're not doing security right now, strictly speaking, but yeah, if you're scanning, what you're trying to do is find open ports typically, and then figure out what's going on those ports and get vulnerabilities. And that's a little bit different concept, but that is part of this. We are always playing security. As systems administrators, we're always on blue. We're always playing security. So it's an important thing. Okay, so that's the utilization, saturation, and error methods. Use. It's an easy one to remember, and I'm always thinking, I'm checking this, I'm checking that within a system, okay? So let's get into some of the actual commands, right? So our observation tools, we have uptime. Now, I've shown you guys uptime in a lot of the labs, and again, this isn't so much a hands-on one as a theory one, but we do have the labs open if we need to go look at something. But utilization gives us uptime, and what does it do? It shows us when the system came up. So why might I want to check? Like if I get to a system, I get called out. Middle of the night. For, service being down. I get called out in the middle of the night. Why might I care to know if this server's been up only 40 days or if it's only been up for like 13 minutes? Why would I care the difference there? Does anybody know? Do you guys think that a system that's been running for 40 days probably has a service that just turned off? Well, it got rebooted is very important. That's true. But I mean, they're telling me that a service is down and it's only been up for 13 minutes. It got rebooted. Most of the time, if a server's been up 40 days, I'm looking for something else going on. Like, I'm looking for a person turning it off. But if something's only been up 13 minutes, yeah, the server got rebooted. Maybe that service isn't even set to be on. Maybe that server had been up since the last time they updated it, and nobody actually bothered to check if it was enabled. That's way more common than you probably think. So, you know, when we go and look at services, and I'm always telling you guys, you look at the service to make sure it's enabled, that is a big thing. That's a problem. Yeah, that's hack the planet. Yeah, or what can happen is a service started out of order, or a service required NFS to be up, and NFS wasn't up by the time your web service started, so something didn't come up correctly. But that never happened when they were building it or testing it, because it was always up. Nobody ever thought, hey, while this server's still in test, I should reboot it and see if something's wrong. So now in the middle of the night, for the first time this thing's been booted in 300 days, this happens. It's terrible, but it happens. Now some condition happened where things don't come up. Yeah, so they can be set here. I'm going to show you guys where they're set to come up. So if we're looking on a server like this, right? And we want to look at systemctl status SSHD. Here, right here, we see that it's enabled. We see it's running. It's active right now, but it's also enabled, meaning it will come up when the service comes up. So when our server comes up and systemd is handed over the first process is always systemd, by the way, in modern Linux. Systemd will then go and start everything in the order that it needs to. And I've shown you guys before how we can go see with like systemd, analyze. We can do something like this, critical chain for sshd.service. And we can see the order that everything has to come up for it to come up. Is the service and the process you see using htop same or have any difference? Malvi, the service and processes using htop, I don't really use htop or top or atop or any of those things, but I guess if you're talking about, is that the same service you see if you do like a PS and find a service PID? Yes, it is the same thing as this PID right here. So this process ID right here, 52940, is the same one that will be up on any other thing. I missed something. Or someone misconfigured a service so the dependencies were set in the wrong order. Yeah, that's possible. Is service and the process you see in okay. Active running means it is enabled and running. Yeah, well, so if you see active here, that means it's currently running now, especially since it's got a process ID. Enabled right here, not this vendor preset enabled. This enabled is the one that tells us it's going to come up when it starts again. That's this one here. So that's how you know. So, okay. So, then there's these load averages over here. And the load averages are every one. This is the 1 minute. This is the 5 minute. And this is the 15-minute load average of the system. I think it says it right here. 1 minute, 5 minute, and 15-minute load average. So why might you want to see the system like this? Why might it be useful to see if this is still really high, but these two are kind of still low? What might that tell you about a problem on the system? Or if you get to it and this one's high, and this one's high, what might that tell you about the system? So I want you to think about that. Why would one of them be high and the other one's still low, or all of them high? What might that mean? Or you get there and this one's low and these two are both still pretty high. What might that mean? And this is big in web server space, right? And if you're serving web server and you get a lot of traffic in at one time, it may tell us things. Uptime. Uptime's not one of my commands. You could do commands on the Twitch side if you want to see my commands. Also, I'm drinking a lot of water because I just ate Indian food. I got to stay hydrated. All right. So again, this is, you got called out in the middle of the night. You're checking out what's going on in the system, and you saw that it's been up for 40 days, so it probably didn't just have a reboot. That's good. There's only one user on it, so there's not a whole bunch of users out there. and then you see that all the usage is kind of high right now, but lower for other stuff, that means it's an acute problem. Acute. Everybody knows what that means? It's like a medical term. There's acute and there's chronic. What's the difference between acute and chronic? Does anybody know? If I just like go like this and just snap my arm out real quick and I go, oh, that hurt right now for the first time ever. That's acute, right? It happened like that. But if I'm like, oh, guys, my arm's been hurting for months and it really hurts when I do this, you'd be like, that's a chronic problem and you're a dummy. You shouldn't do that to yourself, right? Does the load average take memory? No, the load average, I'm going to actually explain that here. This is only CPU. This is only CPU, and it's relative to the number of cores. It is not memory in any way. Acute is also a type of angle. That's true. Acute in the medical space means it happened instantly. So, ow, I just hurt my arm. Versus, oh, it's been hurting for months, and watch when I do this, and then you're like, you guys are just like, this guy's an idiot. But check this out. My arm doesn't hurt, but if it did, we clear the screen real quick, and we do an nproc. This is a simple machine. I got one. Acute is small. Yeah, acute is quick. It just happened. But if something's been happening for a long time, it becomes chronic. Those are the medical terms. So I have one processor in this machine, and I'm going to say uptime. And I'm going to say that I have less. So you notice that I have one processor. So I said it's relative. In this box, this is a low load because the 1, the 5, and the 15 minutes are less than 1. If in a one-core system you have greater than 1, that means processes are waiting to get time on the CPU. That's what it means. If I were to do an nproc, so if I were to SSH to some of my systems here, some of my systems are bigger than others. Let's go to, one of my nodes has a lot of, which one of these guys has a lot? Is Streamers still alive? I don't know if Streamers is still alive. Might not still be alive. Yeah, that box isn't alive anymore. Let's go to Prometheus. Right? Prometheus has nproc. He's got 4 processors, and his uptime is very low because this would still be pretty low if it was less than 4. So sometimes you go to a server that has 48 cores, and he's running at 24 all the time across here. And somebody might say, is that high? And you say, well, no, that's not high. That would be high for this machine, sure. But on that machine, it's under load, but it's not under load where there's wait for the CPU. Does that make sense? That's the difference, is it's relative to the number of processors you have. So in this case, these are all low. But I'm just talking about if they were high, if the example did show them high. Why is there 9 users? Where's 9? Oh, my home lab? Oh, I could show you why in my home lab. So my home lab, I have a bunch of users. I only have 3 users here. I have 9 users in my home lab because when I hit W, you'll see that most of them are my user in these different bash. I'm in a bunch of screen sessions, and then I'm jumped out into all my different servers. So that's why I have a bunch. Mayan said, loving your approach here. It's too late to join the grind. No, you can join. We are just, we're in a lab. If anybody wants to use the lab, it's over here. This is one of our labs on monitoring. So this is the lab if you wanted to jump in for free on Killer Coda. It's pinned on the Twitch side, but I'll link it again anyways. And then we're just talking through system stuff. We talked through, this is Linux Systems Administration. That's all we're doing. And we talked about some of these different pieces, and now we're on observability, some of the different tools that are there. So let's go into some other observation tools that can tell you what's going on inside the system, right? And again, like, guys, when I go to a system, I look at uptime, and then I do a last more. Those are the first 2 things I do. You call me out in the middle of the night, I do not care. I go to a server, I do an uptime, and I do a last more to see who's been on that box, to see when it was last set to reboot, or did it crash, or whatever. I need to know these things because that's going to determine every other part of the big directions that I take for the night. What am I looking at? What am I looking for? What do I think happened to the server, right? Okay. Also, for people that did get here late, we do have a Discord. You guys are welcome to hang out down in the Discord, and I'll go post that on the YouTube side. By the way, guys, I've been streaming on Twitch for like 3 years, but Twitch isn't super popular for me. But YouTube is like much more popular. I don't know. I guess people on YouTube like me a lot more than Twitch. Twitch is mostly for gaming, though, at least in my experience. I watch people play Dead by Daylight on here. It's not really a big thing for people that want to hang out and do systems work, you know. But YouTube, I think, has a lot more people that are kind of serious about learning stuff. Yeah. Suresh, you're always welcome to go back and look. Also, almost all of my documentation like this is actually up on the Discord somewhere as well. So if you guys need it, you can get it. So that's uptime. Uptime is this super simple command that surprisingly gives you a lot of information. It gives you a whole lot of stuff. Okay. So here's another one. Here's vmstat. And what's vmstat showing you? By the way, so when you do vmstat like this, the format of this command, as with most commands, is the name. So we do vmstat. And then we can give a number. So in this case, we're giving a 1. And then we can give another number. And in this case, we didn't give one, but maybe like 5. And this right here will be the time interval. So this will be how many times it does it. So that'll be time interval. And this right here will be the number of occurrences. Right? So if it's just like this with the -1, what it's going to do here in this command is it's just going to go every 1 second forever. That's what it's going to do. And then you would hit Control-C to stop it. Otherwise, this will never stop running right here. But if you want to do it every 1 second for 5 seconds, you would do a command like this, right? So I think I have this in my home lab, and we should be able to spin it up in the background. So I should be able to say clear, and then vmstat1, and that'll just run forever, just like that. But I could instead say, well, I want to do it 5 times, so vmstat, and maybe I want it every 2 seconds for 5 iterations, so that's about 10 seconds. But again, it's an exact slice right at that second, right at the 2-second mark in this case. And then it's going to finish. Look, my hands are up here. It's finished all by itself. But what do all these numbers mean? These numbers, you can read them. You can say man vmstat, or somebody like me can show you, right? I can show you what they mean. All right. So here's what some of them mean. R is the number of processes running on a CPU. A value greater than the CPU count is called saturation. What did I say saturation was? Saturation is when your usage hits max. So, in this case, my Hellcat server has 24 cores. So are any of these at saturation? No, this box is chilling right now. Hey, how's it going, Guild? I think I saw you follow earlier. Did I see you follow, or did I see you something? Maybe it was yesterday. Anyways, welcome back. Hopefully this stuff's useful to you. So we got that. And then over here we've got free. That's the free memory in kilobytes. How much free memory do we have on the system? You never want that at 0. If that's 0, then you're talking about saturation of your memory because you have no free memory anymore. Remember I told you when you get to 100% utilization, you start to go into saturation mode? So there's that. I don't know if you guys can hear the ladies yelling downstairs, but something very, very exciting must have happened. All right. Then, these are numbers we almost always universally want at 0, is swap in and swap out. So right here, swap in and swap out, we want those at 0. We do not want our system swapping. Because, here's the thing. Swap had its place years ago. And Linux systems still want to swap, by the way. Swap, though, is you're going to be writing out of memory space to free up memory by writing to disk. Disk, even in a virtual machine, is typically about 1/100th the speed of your RAM. That's terrible. That is this 1/100th, right? That is bad. That's bad. It's very slow, right? It is useful. Thanks. Yeah, good. I hope this stuff's useful to you guys. And then here's a bunch of stuff. Over here, the CPU stuff here is the weight average. So there's user time, system time. Those are the two most important types of time. How much the system's idle. So here's our user time here. System user time here, system time here, idle time. No, hold on. We got to draw it like this so we know. Idle. Yeah, so this system is sitting chilling. So you say, how do you know it's chilling? Well, because its idle is at 100. This box, when I checked it, was doing nothing. It was essentially doing nothing. But I can read that out of this if I really wanted to. How about this other machine that's running Prometheus, my Prometheus box? How's that one doing? Let's go look at him. He's not super idle right here. He's kind of idle, right? This is the third field here. He's kind of idle, but he's doing stuff, right? He's doing stuff. And is he ever saturated? This box, if you remember, has 4. No, this box has 8 actual virtual cores. Oh, I'm on a different node. I'm not on the Prometheus node. What node am I in right now? Oh, I'm in my mini cube box. So this is when I was building up Kubernetes in my mini cube in the home lab. So he's got 8 cores. So he's got a lot more oomph to him. But we can see that information here that this node was completely had a bunch of free memory and was not in any way under high CPU at all. So kind of important. All right. So that's an observation tool. See how much saturation and usage my system has. Let's go to another one. MP-stat. What's MP-stat showing us? MP-stat will show us against all the CPUs. So in my case, I only have 20 CPUs. So this is all 20 CPUs of my system right here. And I can see the user space, the nice, if we care. That's if it's weighted on anything. The system, so these are big ones. The user and the system are 2 of the most important calls. Because user space is all of your user calls against the kernel, and system is all your system calls to the kernel, right? So those are the 2 big ones. If we add any IO weight, that's not a big deal. IRQ, soft steel, guess, gnice. These are all other things that can happen, but I don't really think you really need to worry about any of these for the most part. And then this is another big one. Look, here's idle. Our box was sitting damn near idle at this point. So if somebody were to ask you, hey, and mostly we look at user and sys. So if you look at user right here, and then you look at sys, and then you look at idle, was this box doing anything? Box was chilling when I was messing with it. Had 20, I thought I had 24 cores, but it's got 20 cores in it right here. Unless I might have cut off some on the bottom. But there's all the cores. And all of them are aggregated here, but then each individual core is here. Maybe you want to see if you have like a hot, maybe like these ones are like filled up because all the processes are running there, but these ones are chilling. Maybe there's something wrong with the way that a job got kicked off by a user. And you know, if people aren't running multi-threaded processes for your like high performance compute, everything might be landing on one kernel, and that's a problem, right? Everything's going to one place. Do you need a package to run MP-stat? Yeah, it's sysstat. That's the package. So if you're on a so I'm on a, let's see what type of box am I on. Right, I'm on a Ubuntu box. So over here I might say, how do you do that? I think there's a what provides. So apt. Let's see if they have a what provides. Search all for, what was that? MP-stat. Let's see if they can search for MP-stat. It found SMTP stats. Oh, sysstat, sorry. There's sysstat, I believe. So it is sysstat. There you go. Was not installed, and it was installed and working. Interesting. On Red Hat, I would do a yum what provides MP-stat. So if I was on a Red Hat type system, which is this one, this is CentOS 7, yum what provides, and then I would say MP-stat, and it would tell me where it could find it from if I was connected to something. So watch, it's got to go download all its data from the different links and packages and all that stuff that I have. And once it's done all of its metadata refresh, then it'll tell me that it comes from sysstat. This box is pretty old. I think I've had this box running for 7 or 8 years, so I really need to upgrade it one of these days. One of these days, guys. One of these days, all these things will happen. Look at that. Forever. This also only has one CPU. Poor box. Poor server. All right. Drink some water here. We can do something else while that goes, but we watch it for a second. This is basically me over here while it's running. Yeah, I amuse myself. All right, bunch of debugs. Come on, server. Downloading all your info. I don't know what's going on. Seems like a lot of information for nothing. Anyways, we'll give it a second here. Poor server. Doesn't know what's going on anymore. 7's really old in server world. Bottleneck. I did stream earlier. I was working on, I did some Slurm and NFS earlier today. Now I'm just doing a stream on systems administration stuff. And then I'm getting sidetracked, but I'm showing kind of different stuff as people ask or as we talk about it. This is still just trying to run a what provides, so that's funny. mpstat, systat to provide it, and then run it. Yep. Hold on, should be coming up soon. Also, mpstat, or bottleneck rather. The wife is downstairs with some of her girlfriends, so I am hiding out up here in my office behind my green screen. There it is. Oh, anyways, mpstat comes from systat. Yeah, there it is. So that's the systat package that I could use for my 7.9 box here. Yeah, this is my little hiding spot in like behind my green screen here. All right. So that's mpstat. Shows some good information. And then pidstat. Pidstat's a fun one. Pidstat will show a rolling per process summary useful for watching and recording patterns over time. So what this will show you is at any slice. So if we're doing a pidstat 1, it's just like before. It's pidstat. And then this is interval. So this is interval. And then this is number of, so like let's say 1.5. This is number of instances or occurrences or whatever you want. So if I did this, it would give me a slice of all of the processes that are actually getting CPU time at that exact slice of time right there. And then it would run again. And this is very useful to see, like, Java is using a huge amount of CPU on my system when it gets access to the CPU. So if I come over to one of my other boxes here and I run pidstat 1, I should see what is getting access to my CPU at any given time. Looks like I got some container Docker stuff. That probably doesn't even need to be running. But how about fail to ban? Fail to ban runs on my server. Yeah, it's pretty regular. And fail to ban gets hit pretty often because people try to SSH in. So that kind of makes sense. And then I would expect Promtail, because that's what's sending data out of my system out over into Prometheus. So I could just kind of sit here and kind of see what's going on inside of a server. See what's using the CPU. See if I have a high amount of usage in any respect against any of my CPUs. It's going against CPU 0, which is the only CPU I have. But on some of my other systems, this might be different. If I go over here and I did pidstat 1. Oh, whoops. Let's just install it over here. More like a task manager. I guess you could think of it like when you're looking in Task Manager, you could think of it kind of like that. Yeah, it's similar idea. We're just looking at, for that one slice, what is actually touching the CPUs for that one slice of a second. That's fine. We'll just restart all these services, whatever. All right. So, pidstat 1. So now we'll see what's using this server. What's this server doing? This server looks like it's doing a whole lot more. It's got etcd running. it's actually running Minikube, and there's a Cube API server and a Cube controller. This is running a real Kubernetes, right? I can see actual Kubernetes commands on this box, so that's kind of good. But from here, if I didn't know what this box was doing, or I didn't know what was going on the server, I could very quickly, from watching this PID stat, I can see that's obviously a node in a Kubernetes cluster. It's obviously, look at all the things it's running, and it's one of the I want to say control plane nodes, but what do they call them? They call them the used to call them master nodes. I guess they call them controller nodes now. Yeah, that's very clearly, in just a few seconds, you can see that this is definitely, like, it's running container D and vert controller and core DNS. Those are all things that are in Kubernetes. So very quick, and K-worker, yeah, we're definitely a Kubernetes box here, right? So you could use this real quick to figure out what a server's doing if you lost the documentation or nobody ever wrote it down and you're getting called out in the middle of the day. So look at this. In these examples, some Java processes are consuming massive amounts of some of our CPUs. And that's something to think about, something to kind of know what's going on. All right, and then we have IOStat. So IOStat is a tool. You fix the green screen. FaintCaf, I just pulled it up, and you know what? I turned the light off that was back, and now it's fine without that light on. So apparently that light wasn't helping the Chrome. Yeah, I fixed the green screen. I just pulled it closer to me, FaintCaf. Yep. And also, FaintCaf, I've just been trying to kind of keep the numbers up. So since the wife is downstairs with two of her girlfriends and they're watching like movies and stuff, I'm just kind of hanging out up here. They might even be playing board games right now, which I do love board games, guys. But you know, if my wife's here with some of her friends that she hasn't seen in a while, I'll let them just kind of hang out together, and I'll hang out up here by myself. I'm just as happy up here by myself as I would be, well, probably anywhere. So, okay. Observation tools like IOStat. IOStat does I'll show you guys some examples of IOStat, but IOStat-XZ1, so this is IOStat, and then we give some options, in this case XZ, and then 1. This 1 is the same iteration again. So it's how often is it happening? Every 1 second forever. And with IOStat, there's two things that it tries to give you. It gives you the CPU, so you can have CPU, and it can also give you, right here, can I write out here? Oh, I can't write out there. That's annoying. Devices. Whoops. Hold on. So this is devices. And then we can change it. So I like IOStat with a -C will give you CPU, and with a -D will give you just devices. So this is super useful for me. This is normally how I do this. Right here, so IOStat-XZ with a C would give us just the average CPU. And you might say, Scott, that's like a smaller version of that PID of. Yeah, it's just a thing to see what's kind of going on in our system. And then down here with devices, we can see all the read, write, and stuff for our devices. So let's go look at this. Let's watch this happen on a system, because, again, we're dealing with observation tools for Linux systems administration. This whole thing right now is like more of the theory than my normal labs, which are all hands-on. And this is observation tools. But if you have a lab, if you are in one of our labs, which I do have some of our labs pinned, you could be doing these commands right in there. You just might have to install IOStat. I already have it, so I'm going to clear this up. And I'm going to do IOStat-XZ, and it would give me some information. And that's hard to see because of the way that it rolled on the screen. But maybe I clear it, and then I run it again, and that's still hard to see because there's not enough room on the screen for it. So let's give it the whole screen here. Maybe the whole screen it'll fit. Nope, still not going to fit. I can actually do one other thing. I can change the settings here. Hold on. Appearance. We'll change it down a font. I know people don't like when I do this, but change it down just one font. Hit apply. And maybe still not fitting on one screen. Jeez. Almost one more character, guys. Still couldn't. Oh, it finally fit. Okay, it fit on one. Very close. But we could do 1 on that. And now for every 1 second, that's going to operate against what's going on. But I want you guys to see something here. Do you guys notice that the very first time it showed all of the devices, but now all these other iterations are only the devices that are getting used? So what I mean by that, watch this. Clear the screen. The first one is going to be monstrous, all of them, but then now it's only the device that's getting read from at that time. So sometimes it's only one, sometimes it's two. DM0 and XVDA actually map to the same device, so they should be very similar numbers across there. Well, they're almost the same device, actually. They're not exactly the same device because XVDA is the unpartitioned disk. Don't worry about all that right now, but they're very similar. You'll see very similar things because XVDA is the entire block device and DM0 is just the root directory. But anyways, hey, Robodom, how's it going? We are just running through systems administration stuff, and I just wanted you guys to see this. So that's IOStat with the devices, but watch if I just do the CPU. So now I can see just the CPU information, and I can see that this device is really just sitting there chilling, right? So it's just kind of hanging out, not really doing too much, mostly idle. But I could also see that the disks are mostly idle. But I have, as we look at these, I have the reads per second and the read in kilobytes per second. I forget what the RRQMs are in some of these, but over here I should have the writes. Where are my writes at? Here's my writes per second. So my reads per second and my writes per second are huge. But my reads in kilobytes per second are going to max out at some point, as are my writes per kilobytes per second, right? But I want you to think about something. When I talked about it earlier, I said utilization is between 0 and 100%. And then I said my saturation is when I'm waiting. And then I said that my errors start coming after that, right? That's the use model. Is this at 108 kilobytes per second likely all of the utilization? And the answer to that is no. And you might say, well, what is the maximum utilization and how would you find that? Well, I can actually do some tests to see how fast the system can read and write. And I've shown you guys how to do that before with DD and other labs. But we can push and see how fast the system can read and write when it's going as fast as it can. And then we could come over here and see if these actually go red. Are we actually hitting the maximum read and write speeds? And then we can, this is one of these things where we can just test it till we find what the maximum speed is, right? Because I've done these calculations before. I've worked with salespeople and sales engineers, and we've calculated exactly how fast from one device all the way over to the storages and back. But guess what? We can calculate that crap all day. At the end of the day, when we put it in and we get everything connected, that's my final test for how fast things actually are, right? So, all right. So I'm just trying to show you guys that there's a lot of things here, and there's a lot of, man, there's so much you can read out of some of these tools. Might seem like simple, stupid, and you're like, I graduated past that. After 5 years, I never had to do uptime again. I'm like, guys, I use uptime literally 500 times a day. Every time I jump into servers, I have things that go out and check my servers to see how long they've been up. I check the uptime in my home lab right here. Look, I have a bunch of servers that need to be updated. I haven't patched them in 141 days. That's facepalm for me, right? But I'm gonna get these labs under control here soon, because I'm gonna start making this very visible to our Discord so that people can see and start to get into our environments. Also, I'm going to take a break here in a second, and when I do, I'm going to go figure out how to get a hold of our damn Guacamole, because I forget how to get in there all the time. And when I do that, we will be able to get access for people in the Discord that want to get in and do stuff on our systems. So I'm going to make that all. I mean, that's all available now, but I'm going to try to make it more available, because I'd like people to use the systems and see some of these things that they can do. And then, as long as people aren't using them maliciously, literally the worst thing that can happen is I just blow the servers away and rebuild them. That's all automated, right? I have that process all built. I just need to turn it on, really. All right, anyway, so there's my poor little lab boxes that we don't mess with, but all the other ones are up. Okay, then the next one is SAR. SAR is a great tool. Do you need to patch those servers because they need to be updated? Yeah, Robodom. If a server hasn't been rebooted, there's one thing for sure. Does anybody know what the one thing for sure, if a server hasn't been rebooted, that has not been updated? There's one thing that for sure has not been updated if a server hasn't rebooted. I'm going to leave you guys thinking about that for a second. And I'm going to go on a quick break here. I'm going to put a little hourglass up. Here's my hourglass. And I'm going to say quick break. Quick break. and stretch. It'll take 8 minutes, all right? Yeah, you definitely have not patched the kernel. That's true. You guys are right. 100%. You did not patch the kernel if you have not updated the system. That's true. You're on the same running kernel. A few of you guys got that, and that's good. All right. Robodom, it's definitely the kernel, yes. All right. I'm going to take a break real quick. I'm going to stretch my legs, go see what the ladies are doing, maybe grab a Monster, and I will be right back. You guys, Robodom's in charge. Robodom, tell them about the Discord. Let them know that the Discord's free. All right, where are we at here? Still on a break. Taking our time. Observability tools. Observation tools. I guess I changed the wording. Let me see. Yeah, okay, observation tools. Fair enough. That's what we're looking at today. Still on a break. Smoke them if you got them, all that good stuff. Twitch people, feel free to go to YouTube. YouTube people, hang out on Twitch, whatever. You guys are allowed to cross over spaces if you want to. All right. Then let that timer go in case people went and took a break. All right. Give people a few minutes to come back. So SAR will show you all kinds of stuff, but I'm using it here to show me network information about my different interfaces. We'll give it a second. I'm trying to slow down, make sure people have time to get back from a break. I'm sure other people wanted to take a break and walk around for a minute, so I'm going slow, and we'll get back to it here in a second. So, got people on the YouTube side, people on the Twitch side. I appreciate you guys that hang out, talk shop. Robodom, that's 100,000 views. Not 1K, it's 100,000. Yeah, it wasn't 1K views, it was 100,000 views, Robodom. If you didn't see that. Yeah, Bassway, you said, is there a way to upgrade the kernel without... Yeah, there's a thing called live kernel upgrades. But, man, I'll be honest. I haven't seen that run in production. You can do it in Apache. You can do it in some of the Amazon machines. But most of the time we don't do it. It's 100,000, Robodom, yeah. I have one video with 70,000 views now. Yeah. Yeah, in only under 3 weeks. It was wild. Yeah. So that's one of the reasons I've been kind of motivated on YouTube, was to just kind of keep hanging out. Yeah. Yeah. So it's funny because Twitch really did grow slow. But I think it's just because people aren't on Twitch to... I mean, people aren't really on Twitch to watch, like, learning stuff. They're on Twitch to watch Dead by Daylight, and people do Fortnite dances and stuff, and hot tub streams and stuff, you know? Like, that's what people are on Twitch for. YouTube, you get a lot more people wanting to learn stuff, I think. Suresh, there's probably a fair amount of people in other countries, because I get a lot of viewers outside of the U.S., yeah. And it's 98.5% male. So, I would try to attract other viewers, but apparently it's men that want to see me and want to, yeah. This is a carefully put together package for the men out there. No, I'm just kidding. That's terrible. But anyways, let's look at SAR here in a second. Yeah, waiting on the hot tub stream. So SAR-N dev 1. So let's try this one real quick. So SAR-N dev 1. And that should give us all of the devices on the system, right? And that's running every 1 second, but maybe I want to see it. And then, by the way, when I hit Control-C, it gave me the averages. Let's give it every 5 seconds here. So then it'll go a little slower. But this will still, every 5 seconds, tell me if there's any transmitted packets or received packets. So RX is always receive. Transmit is always TX. That's always true. Here's the actual receive kilobytes per second and transmit kilobytes per second. So if you're looking at that, you will see different numbers here than you will see down on your actual line, because this is kilobytes per second, which is an aggregate, whereas you will always see kilobits on the line. So you would see 8 times as much down on the line that you would see here, because this is aggregated up into bytes, which is 1/8 the size, right? Hey, Johnny, man, how's it going? We are just hanging out, and I'm about done with my break. And I was just kind of running through and showing some SAR. Oh, there's my break and switch, and hit reset and just go down. And we can SAR dev, and we should be able to see, I think we can do TCP, is that right? So we can see TCP here. This is a fun one. Every 5 seconds. But then we can also do, watch this one, this is a fun one, eTCP. So I'll give you guys these commands to look at as well. I'll drop this over on the YouTube side and on the Twitch side. How's it going, Ewo on site? Thanks for stopping by. All you guys that are my regulars on Twitch, I appreciate it. And we are just looking at system stuff. And SAR is great. Watch here. Here it's going to show me all the normal transmissions and all the error transmissions on TCP in my system. So if I suspect that a server is not really communicating well with like a backend database, or I just think that there's something wrong with the way that I'm communicating with storage, I can just sit here and look, and very quickly you guys can see a bunch of zeros. There's zeros on all traffic, which is my active. This is my normal traffic. And then these are my failed or retransmitted traffic. So real quick, you see I'm not really passing any traffic. That's acceptable. But I could see really quickly if I had high errors on something. Hold on, I missed over here. Mohammed said, currently studying for machine learning or NLP engineering, want to be an overall strong software engineer and not just an ML. How much of these systems admin videos and tools do I need? I will tell you, Mohammed, that I am not strong on any of those topics, really. I do all the systems. I do all the stuff underneath that people build that stuff on top of. So I am good for that. These videos, I think, will help you with the Linux side of things and building your environments if you'd like to build your own environments. But I'm not heavily into a lot of those topics. Although we do have guys in our Discord that are involved with large language models, and one of our guys builds bots and all that kind of stuff. Can we specify specific protocol numbers with SAR? I don't know, less than T. I've never tried to go that low, but we could read the man on SAR and figure it out. Typically, if I want to see specific protocol numbers, I'll go dig in on TCP dump, and I will see just the stuff for TCP dump that I want. That's typically how I'll do that. So Sandeep said your teaching style is great. Yeah, hopefully this stuff's useful to you. And then, you know, the goal of this is to show you guys that you can learn a lot of stuff just by getting your hands on it. And Killer Coda is maybe the best thing on the web for getting your hands on this stuff. You don't have to set anything up. You just go into Killer Coda, and it's free. And it's like just like the best ever. So, okay. I think. I'm going to hit Control-C on this just to stop it. It gives me all the averages. Look, we had no errors that entire time we were running, and we only had a couple of little bit of passive traffic being sent. Nothing really going on. So SAR gives you some really good information. Also, if you're running SAR on a system, it will give you aggregated numbers for every 10 minutes. There's a thing about SAR that's good. It's good to see how my system performed over time. It is very bad to see acute instances of high load. So like if your servers spike at night because somebody's trying to get in or something like that, SAR won't show it. SAR will show for one 10-minute block like 99% idle, and then 97% idle, and then 99% idle again because it's every 10 minutes aggregated. That is not super useful if for 3 of those minutes you were at 100%. But you just don't see it because there's not really that much kind of being shown there. So, okay. Oh, we had a Ranger check. Hold on. Ranger check. That means we got to go check on how Ranger's doing. How's Ranger doing? Ranger is not in his bed. Probably because the wife is downstairs just to the left over here with her friends in the kitchen. Well, they're over actually in like the dining area where our game room is. If you guys haven't seen our game room, hold on. This will be fun. Let me see if I have game room. Hold on. Let's see if I have. There's a lot of, well, it might be hard to find. Board game. Let's see if we can find board game. We have a lot of board game stuff, but let me see if I can find where my wife put together the board game. Oh, that was when we got our little, I don't really like those very much, but they worked for when we got them. Do I have the wife? Oh, that's the old Ranger cam right there. Back in the day, that's what Ranger cam used to look like. Hold on. People hacking. No, I don't have it. I'd have to go look for it. All right, doesn't matter. We'll find it another time. All right, so we looked at SAR. Oh, so there was network tools with SAR. We did that. And then there's also the error tools with SAR. And this is what I was showing you guys. It's a summarized view of active, locally initiated TCP, passive, remotely initiated TCP, and then retransmits of any TCP. So if we suspect TCP errors, we can find that very quickly. And then retransmits are a sign of network or server issue, maybe an unreliable network destination, server is overloaded and dropping packets. There's a bunch of things that you would expect to be going wrong if any of these numbers were going up on our system. So that's a good thing to note. This was a little thing that I showed it, but I didn't get to this slide. All right, so let's talk about, these are all the things that I just showed you, but they're kind of, again, I'm kind of showing them again. And they are for the big four. So I said CPU, memory, disk, and network. So if you wanted to look at any of those again, you can go actually look at it. And we mostly looked at utilization and saturation. We didn't actually go down into errors so much, but we can see a bunch of the information. There's the information there for errors. So utilization, saturation, and errors are a big part of our system. Utilization, so when we look at, hold on. Utilization is always 0 up to 100%. That is your U, right? Then as we start to queue a line across, that's your saturation. And then when you start to see errors, those are your errors. So that's your utilization is 0 to 100. Your saturation is as you start to get into a queue and you're waiting for things. And then errors are timeouts start to get hit and BS starts to happen in your system and whatever else. So these are some of the things that you can do to check those in your systems. Okay. And GitHub page. Suresh, I have this up in the Discord, and if it's not up there, I'll put it up there later tonight, if that's okay. I'm pretty sure this one's up there, but I'll put this up in the Discord, yeah. I like to just put the things up where you guys can grab them and that kind of stuff. Hello, guys. You build systems, pseudo. Yeah, Black Shell. I build a lot of systems, in fact. That's mainly what I do as an engineer, yeah. So you guys are welcome to hang out. Yeah, and then right now, yeah, we're kind of going through observability and Linux systems administration type topics right now, yeah. So, okay. Observability. So these are things that I think you should want to know. In a lot of the different labs and different systems that I've talked about, been doing a lot of Linux and Azure recently. Nice, different Dagger. That's good. Yeah, that's actually a good place to do it, I think, because there's I think cloud in general is just a good thing to know right now in the industry. I think it's been a good thing to know in the industry for the last 10 years, but I think it's really good right now. So definitely understanding how the cloud works is valuable for you guys. Yeah, Microsoft loves Linux. Yeah, I was there at the Red Hat Summit where they were the keynote, and super weird. But okay, so you could go do all these commands on a server and just see. And this is one of these things I like to say is like, do you know what system you're on? Do you know what distribution you're on? How much memory do you have? How many processors do you have? You should be able to answer these questions and be able to go through that. What did Bottleneck ask? Hold on, I missed Bottleneck saying something. Was I on break? Linux is bare metal just logged me out randomly. That's been happening to me a lot. What command would you recommend I run to see what happened? Bottleneck, you got logged out of your system randomly? I guess I would say how are you connected in? Are you at a console or are you SSH'd in? And that would determine the next steps that I would do. So if I was consoled in and I was getting logged out, I would be very wary of something happening on that system. And if I was just SSH'd in, I would say, are you restarting something? Are you messing with network? Because that's going to kick you out every time because you're over the network to connect in. And then if you drop the network, obviously you're causing your own connection problems. So I would think about how I'm connected to it. Is full GUI Kali on bare metal? Yeah, you shouldn't be getting kicked out of that Bottleneck. Maybe there's some kind of timeout. Maybe you're hitting some kind of timeout and it's locking you, but I don't know. Maybe I'd go to the Kali forums and see if anybody had ever, if there's some tool in there that logs you out after so much time or something. Maybe there's some troll that got built into the system that, if you don't touch it or you're just watching the kernel for X amount of time at like the command line, then it locks you out or something. That could be possible. Might be a PAM issue. Fair enough. Okay. And then we got a question about analyzing logs. So how might you analyze logs? Let's go look at that real quick. So I get asked a lot as a systems engineer and administrator. I get asked a lot to, hey, I tried to log into a system, right? So cd var log. And in here, there's different, depending on which system you're in, you're going to have different logs. If you're an Ubuntu or Debian style system, you're going to have var log and you're going to have syslog here. Syslog is going to be your log for messages. And then if you have an auth log is your secure log, right? If you're in a Red Hat, a CentOS, which is dead, Alma, Rocky, Fedora, any of those boxes, you're going to have a var log messages. That's going to be where messages go and errors. And var log secure is where login information happens. So if a user can't get in on this box, and I was just expecting a bunch of attempted logins, I might go in here and I might just maybe tail -30 var log auth log, right? Auth.log. And then now I could look in here and I could see, root disconnected or whatever happened at whatever time. And I could see somebody trying to get into my box. In this case, I see that there was a public key accepted for root, and I can see that root was able to get in on some system or whatever, right? In fact, that's my last login right there. Well, but then people were asking for how would you maybe go dig through the logs? So maybe I would grep through this log, and maybe I would just grep -I for failed. So maybe I just want to look for failed in an upper or lowercase setting. I don't have any failed. right? Because failed is a very common thing if somebody fails to get access. And then I might go look for user. And here's all my user information. All the users that have ever attempted since this last rotated, since this log last rotated, the only user to ever try to log in here was root. That's what I expect. This is an internal thing in my home lab. Only root's trying to get into this box. And this is logged, this log rotates for the last day. Now, you might say, Scott, how would you know that that only goes for the last day? Well, watch. What if I did something like this? And this is one of the things I told you guys. This is why it's so good to understand your awk and your greps and stuff. I could go like this. I could say cat var log auth.log, right? Just catting it out. And then I'm going to pipe it through an awk, and I'm going to print out the first two fields. So 1, 2 with a space, just like that. And now I have all that. But let's say that was like way too big to see. Then I could sort those, and then unique -c, and I would have a count of all my logs. So if I had, watch this. Let's go look at all the auth logs in all my system right here. So these are all the auth logs that are in here. There were some other ones. Now I'm going to run against all of them. Oh, some of them are... Hold on. Some of them are zipped up. So that's not going to work. Let's do varlog auth. We could untar them. So unzip, gunzip. We'll just do each of them real quick. Gunzip that guy, gunzip that guy, and gunzip that guy. Right? Just for fun. Oops. Right? So now they're all unzipped, and then I'll run that same thing because that's kind of funny that happened. And right here, this will do that same thing, but now when we look through, we see here's how many occurrences of each of these things there are for each of the days from April to May. And they're ordered weird because that's, you know, just fun. But these are for each of the things, and these are all the entries for each of the day. Senam, yeah, I'm dropping gems on you guys. Yeah, I'm trying to give you guys stuff that's useful. Did a fresh install yesterday and it logged me out anyways. I'm looking at NVIDIA drivers journal CTL. Seems to have given an error related to NVIDIA. Yeah, bottleneck, that's super weird. What I might do, bottleneck, if I were you, is I would make sure that, because you're logged in at the console. So what I would do is I would maybe make sure that SSHD is running, and I would log in. And then I would also check my logs, see, because if Pam does any actions against your user to kick you out, it will be in varlog. You're on a Kali box, so it should be... Kali, I think, is Debian under the hood. I'm not sure. But if it is, it should be in varlog auth. So you should see it kicking your user out. So there's that. Cat varlog grep root. That would work. Don't understand 90% of things going on, but it's funny to learn about this. Mariano, the goal of this is to get you guys getting your hands on this, so you guys can do that. Yeah, Kali's Debian. Okay. Yeah, so I would go make sure I have another way in just at a console, and I would watch the console, and then I would watch if I was SSH'd in or whatever, and I would do a tail-f on varlog auth.log and just watch it, and then log back in, and then when I get kicked out, I'd look in that log for something to have happened. That's what I would be doing. So, Save Fenton, Mariano, all you guys over there, hopefully this stuff's useful. Suresh, it's okay if you do Windows. You can still like Linux. It's okay. When you start your system, computer. Yeah, so there's dmessage. Dmessage is when you start your system. Dmessage. And then we can look at that through head to see how our system starts up and how it boots up and all that good stuff for people. Adam Hamilton, you didn't miss much. We're just going through, we're doing systems administration. So Linux Systems Administration presented to the Professional Linux Users Group, which is pretty much anybody that joins the Discord. We're not a very exclusive group around here, guys. And then administration tasks, and then just the utilization, saturation, and errors method that I like to use, which is called the use method. And then we just walked through a bunch of tools, and I just kind of drew on the screen like a madman until we got down here to the big four. That's all you missed. That's like the last hour and 20 minutes and like 30 seconds or so. All right, so we were down here on observability of a system. You use Ubuntu, that's fine to use Ubuntu Black Shell. That's fine with me. You'll find that I mostly use Windows to get into all my systems, so I don't care. Actually, I don't care what machine I'm sitting at as long as I can get to this right here. As long as I can get to a black background with whatever, I can do anything I need to. And if you guys, I mean, some of you guys might think I'm exaggerating, but I literally control thousands of servers from a screen like this. This is what I do. This is all I do all day, right? This is my home lab, though, but we will get some of this other stuff working. I'm going to be getting more of you guys into our professional Linux users group labs that we've been setting up for the last few years and stuff. Get more of you guys in there, so... base guy, this will be there. Yeah, this will be in the Discord. In fact, let me, as soon as I'm done with this, I'll load it up there in the Discord. If somebody will hold me accountable, I'll drop it in there. Cheeto Bandito, how's it going? Over on the Twitch side. Yep, I try to get most of the stuff up there, and if I don't have it up there, it's mostly either an oversight or I just don't think it's good enough yet. But look, these are the questions we ask about a system. These are the things that we ask about, like what's going on, and then being able to go through that. Yeah, most of them are down the presentation channel. Yep, it's true. Okay, so then observability summary. Here's all these commands you can do. You can check the uptime. You can look at the D message to see if there's any recent errors. VMstat, MPstat, PIDstat, IOstat, all of these commands, and you can set the timing interval for them. So you have tremendous amount of control across all of these. So feel free to grab that as a screenshot. Again, hold on. You know what? I'll do this real quick. Hold on. I'm gonna discard everything. I'm gonna hit save here because I made some changes earlier. Hold on, just so nobody thinks I'm lying to them. I'm gonna grab this Prolog presentations. This is my Linux systems administration right here. I'm going to copy it right. Actually, I'm going to grab it and throw it in Discord. So if any of you guys are in Discord, here's our presentations. I will drop this in there. Whoops. Where's that? Hold on. I'll drop it in there right now. Linux System Administration. Boom. I'm not a liar. There you go. So there it is. So it's right there, Linux Systems Administration, same one that we're on. So if you guys needed the slides, there you are. If I told you guys before, if you go into my Discord, go into the Professional Linux Users Discord, and you just grab everything like a cartoon villain, and then you run out of there like playing with your little mustache, going yeah and yeah. It is what it is. You guys can steal whatever you want out of there. The goal of this is to get you guys that want to do this into professionally doing this, right? All right. So anyways, there it is. Yeah, some people think if you use Linux, you're a hacker. You can hack and use Windows or any system. That's fair, Black Shell. Sure. I think so. Some of you guys have heard me talk about what being a hacker is. Being a hacker has very little to do with getting into systems. It has to do with the mindset of bending a system to your will. And I talk about that in some of my other presentations and stuff. But observability. Now let's go into testing methodologies. So how do we test things, and how do we make sure that we're objective in our tests? Hold on, we got a Ranger check. We want to check. Ranger is not on his bed, guys. Ranger is out. So what's happened is my wife has friends over, and there's other stuff going over there. Cartoon character joke was too funny, which I don't even know what joke we got anymore, guys. I've lost all the jokes. This is me. I'm just a guy who's a hero for fun. That's me. Yeah, Ranger's out looking for snacks probably, and he's out. He's hiding. He's over there by the wife and her friends because she's got some of her girlfriends. And they have not started their movie yet. When their movie starts, I've got like 2 hours left. They're still playing games down there. So I'm up here chilling. You know, I'm up here. I'm streaming for the long haul. Windows admins are afraid of Linux loss. Linux admins hate Windows, almost gag if they have to use it. So odd. Yeah, base guy. I tell people, as you do more and more systems work and as you get further along in engineering, you'll find that you don't care what the tool is that you get to the tool that you use. Like, I don't care if I don't even use Mac, but if you drop me at a Mac, I'm sure I'd have some button pushing to do to figure out that single button. But after you dropped me in a shell, I would be just fine. It does not matter to me. The method of tool that I use to get into this is very simple. Once I get here, I can do whatever I need. So I try to tell you guys this. Like, I don't care. Like, some of you have probably astutely noticed I am using Windows. It doesn't affect my ability to do good engineering, right? In fact, you almost always have to interface with systems anyways. Systems and business and all that kind of stuff. So you guys will find me using all kinds of stuff. But you will also see that I can do anything I need to here, right? And that's kind of I I think like a mark of doing this for a while. So let's talk about testing methodology. We did systems administration a little bit and all this observability. Let's talk about testing. This is valuable for system administration. This is valuable for engineering. This is there's a lot of methodologies out there. I'm going to show you mine. Mine is super simple. Guys, I'm not terribly clever. You will not find me showing you 30 ways to do something. I will show you the one way that works for me. Because there's this old saying. I love this saying. I do a sport called Brazilian Jiu-Jitsu, and people are always comparing it to chess. So let me explain to you something from chess. I heard a thing very early on in my life. I really liked this, and it was in chess, a good player is 10 moves ahead. And I was like, oh, that's cool. That's clever. A good player, 10 moves ahead. I want to be 10 moves ahead. A master is only 1 move ahead, but it's always the right move. And that's kind of like how I feel. I don't need to know 100 different ways to do something. I need to know one right way, right? So I try to be very good at one. Yeah, I also started up a base guy. I didn't start out as a Windows guy. I started out as a network guy, but I used a lot of Windows stuff in my networking. So, yeah. Rangers hiding, Rangers getting table scraps. Yeah, okay. So here's my testing outline. This is how I do systems testing. This is how, like, if you said, hey, Scott, can we test something? This is how I would do it. All tests seek to record accurate information about the state of a system. That's what we want to do. In fact, I would argue when you're gathering metrics are just measurements of a thing, right? That's just technical way of saying a measurement. If you are not accurately measuring the thing you're testing, you're not actually doing a good test, right? That's a thing right off the bat. Good testing methodology will ensure that we're accurately gathering information. We want to scope, collect, store, aggregate, and control all of that data collection. And this is how I tend to do it. Mostly Active Directory side. Yeah, Suresh, we're not going to hold it against anybody for being Windows admin. I might make jokes every now and then about clicking next, finish. And that is a Windows thing. Because back when I was a Windows guy, that's all I did. I just hit next, finish. And everything worked. So it thinks I'm saying XXX. I'm saying next. Whatever. My closed captioning will not let me talk trash about Windows, by the way. Also, funny story. Maybe I won't tell the story right now, but FaintCalf is here, so I like telling the story when he's around. When FaintCalf used to play Destiny with us back in the day, he had a very funny name, and Microsoft found out about it, and they changed his name to FaintCalf. So he's kind of just leaned into it. But he used to have a really funny name that dealt with Microsoft. Let my Windows systems admins, they create users accounts and reset passwords so I don't have to. Yeah, hack the plan. I tell people all the time, as a Linux engineer, I try to stay out of identity and access management space. I provide the way for them to get in, but then I back far away, and I do not create users and any of that stuff. I let that happen over there because their system's very good for it, so I'm fine with that. Yeah, Suresh, you've been using PowerShell? I have some PowerShell stuff up in our Discord. I don't advertise it very much, but there's PowerShell up there. Press and hold to return is faster than clicking. Fair, Bassel way. Yeah, I agree. Setting up SSSD is awful. I actually have set up SSSD a few times at companies, and every time I've done it, it's been successful. But the harder one for me was Samba and Windbind back in the day. Samba and Windbind were harder for me. SSSD was easier for me because it's just connecting up. And nowadays, if you use Red Hat, which a lot of people do, IDM is free. So you can use IDM and just connect to that, and it's super easy. Then you only have one trust thing to set up. We'll do that in another lab sometime. But actually, I'll have to probably do that in my home lab for people because I'll have to give them access to set up a thing. But I have not had a hard time with SSSD. But I also come from the Windbind Samba time when it was much harder, if you ask me. But those are my thoughts. Anyway, so here's our testing outline. These are the 5 things I do. If you tell me to give you any type of test, these are the 5 things I'll do. What's the purpose? Why are we doing the test? If I write that out and then I go to you and say, is this the purpose? Is this correct? You can fix me. Especially if you're like a manager or something. You can go, Scott, you know what? You're an idiot. And I go, fair enough. I need to change my purpose. So we change the purpose over. Then that helps me to find what's in scope. How are we conducting the test? What is captured? And then that helps me to find out what's out of scope, what's not captured. And look, what's out of scope, you don't have to say things like how many rings are on Saturn. Like figure out how many rings are on Saturn. That's Saturn, that's unrelated. Or how many million miles is Venus from us right now? That's unrelated. We obviously don't have to say that. But in scope and out of scope might be something along the lines of we're capturing all the memory and CPU data, but we're not so worried about disk and network. And those may be things that you mention in your out of scope, because that may be something that's not always thought of. Like if somebody's doing, maybe we're doing static application security testing, and all we're doing is going and looking at the code to make sure that there's nothing bad in there going on. Well, in a SAST versus a DAST test, so static application security testing versus dynamic, in a SAST, we don't care about the system when it's running. The only thing that's in scope is the code that's uploaded to our Git. But in a dynamic application security test, it's a black box test. It's when the code is running. How does it behave in the wild? So those are two different types of tests, and I would have different things going on there, right? By the way, I have other talks on that stuff, so I know I'm talking kind of fast about things, but those are other things that are there. Anyone have language you like? Black Shell, down in our Discord, there's a lot of people that talk about programming, so you're welcome to go in there and talk shop with them about. I don't do any. I mean, my most used language is definitely Bash, and then my second most used is probably YAML inside of Ansible, and then probably a distant third in engineering is Python for me. So I'm a guy in the company managing Windows IAMAD. Yeah, Suresh, it happens, right? And then eventually, hopefully, we move you over into doing Linux, and then you sit around and just realize that you're the best guy in IT, right? That's kind of a thing. Zig looks like an interesting language. Interesting. Okay. Out of scope, and then methodology, description of how we will work to objectively determine the quality of outcomes, right? Are we using quantitative or qualitative results, and do we know the difference between them? And then what normalization points are we using? Are we going to a certain percentage? Is the maximum value always a 10? Because people joke around and be like, I give 110%. No, you fucking don't. Not in one of my tests, you don't. You go between 0 and 100%. You don't give more than 100%, right? Because that wouldn't make any sense. If you can go over 100%, we need to change the percentage, because percentage is a part of a whole. It's between 0 and 1. If people can't figure that out, it's between 0 and 1. It's the same thing. It says the same thing. It's just the math is a little different, right? But the point is, you have to lay that down sometimes, because people try to put like an 11, and you're like, we can't go to 11. I know what he said in that video. I know he said, but it goes to 11. It was still just 10, though, right? Like, you got to understand that. It's still just 10. All right. Control. What will we put in place to ensure that collection is done against a similar environment in different things, right? By the way, my company, Redline, our motto is Redline goes to 11, so that's actually kind of funny that I make that distinction. All right, so this is a testing methodology. Some of you have seen this, but I'm going to pull up for you guys an example, because it's only so good to show you that. What if I show you an actual example from our Prolog presentations? This is when we go and we find a high-performance compute engineer in our organization. I've shown you guys this before. And this is my actual write-up. This is my actual write-up here. Get out of here. Come on, get out of the way. Trying to see our closed captioning. People want to hear what I'm saying. This is my actual write-up of this. So comparing the things that I just said to this. Omaro, did you change your name? Out of context question, I use W and see the number of users. Is it accurate? Yes. W and who will both give you the number of users. However, one of them doesn't work in a smaller column format, so I forget which one it is, but shrink your columns down under 80 and do a W and a who, and one of them's going to error out. I always forget which one it is. But they are accurate. Yeah, they're both accurate. They are accurate. They will tell you how many users are on the system. They'll also tell you if they're directly connected or in a virtual terminal as well. All right, so you're looking at that. This is actually something I use to look for high-performance compute engineers. I wrote this up for a company I was working for. Purpose, we're going to select an HPC engineer. Scope, technical questions to determine capability to execute the job duties. That's what I wanted to do. Figure out if they could technically do it. What did I not want to do? I didn't want to see if they like cats or dogs. I didn't care if they show up at work at 9 a.m. or 6 a.m., that's all stuff that other people can ask. This is the way that I do this, right? This is the way that I do it. My methodology, how am I going to collect data and make sure that it's accurate? We're going to use the same objective questions, and we're going to ask them to the same people. We're going to normalize them to a 35-point template. They can get 5, 3, or 0 to 1. We will add them up at the end, and they will get somewhere between 0 and 35 on my little template. This is how I do all testing. All testing that I do looks something like this. And then the control. Same questions will be asked of both all candidates in the same reasonable time frame. Then I have how I got them, but I never pulled that over on this one. Minimum qualification. That's hilarious to me. And then this is what it might look like as I ask them the different questions. And this was for a senior high-performance compute technician in our environment right here. So I'll leave that for a second. Also, I'm going to cough for a second. Hack the planet? I don't know, because I never get asked for personality fit. I'm always just technical. That's all I want to do is ask technical questions in general. And I think I told you guys this, like, embarrassingly, and kind of embarrassingly, I just found out on Monday that I got passed over I was going to a NASA project within my company. My company has this NASA project, and I went and interviewed with 4 of their engineers. I thought I did pretty well on their interview. They chose to pass on me, and I'm like, oh, okay. And their feedback was they didn't think I was senior enough, and I'm like, huh, okay, fine with me. I mean, I was super surprised, but you know what it is what it is. Okay. All right. Yeah, Mariano, I have some friends that do leak code stuff, and that's pretty funny. Yeah. Most of them do C++, though. So, yeah, Robodom, it was weird, man. Yeah, I don't know, it was weird. I have a whole bunch of gray hairs, actually. They keep popping up. And they're in my beard a lot, too, when I grow my beard out, so. I don't want any more gray hairs if I can avoid it. All right. I missed some follows. Mondo Chandan. Hopefully this stuff's useful to you. All right, let's keep going. So anyways, this was mainly for me to show you guys how I do a test. This is my testing outline. It does not matter to me what you ask me to test. I will put it into this template. Zugod, you started the Linux lab today. Nice. I hope they work for you. You can ask questions down in the Discord. Even Suresh was working on some stuff earlier. The goal of this, again, gets you guys into doing this stuff. And the more hands-on you get, the better you're going to be prepared to answer any questions that come out of the gate. The better you are to answer pretty much anything you need. So that'll be good. All right. So again, back to our testing stuff. I don't care what you ask me to do. I will apply it to this. Because even if I can't make everything fit, this still works for damn near everything I want to do. I want to be objective. I know I want to be objective. I don't want to be subjective. I don't just want to be like, I like Robodom the most. Let's hire Robodom. That sounds good. But that's not like the way that we should run a business. We should hire the best person for the job. And this is the way to do it. We should make the best decision for our environment based on the storage needs and the speed requirements and all these things. And I can do testing of any of these different things. We're going to do some more with testing here in a little bit, especially with benchmarking. But I just want you guys to think about this. Purpose, scope. That could be in scope and out of scope, but it's scope, out of scope, methodology, control. Okay? They measure senior Linux technicians by the length of their beards and degree which they are unkempt. I was pretty unkempt for the meeting, but I did have a collared shirt on. All right. Yeah, Robodom's been being one of our mods for like 2 years, but now we're going to make him interview for the mod job. Yeah. It's terrible. Okay, benchmarking. So how do we benchmark a system? Well, I want to point out, people tend to use benchmark and baselining interchangeably, but I'm not really a big fan of that. You will hear me use them interchangeably, but let's make this distinction for most of my stuff. Okay, benchmarking tends to be, for me, the process of testing the upper limits of a system capability. It can be thought of high water marking or load testing. We benchmark, we hit the gas, we see if the system still operates under a load. Baselining follows along with the observability before to see how the system works under normal operations. This can be thought of as low water marking of the system. Like, how is the system throughout the seasons, right? Baseline should be captured with telemetry and observability systems so that high and low deviations from the norm can be observed. Let me show you what I mean. Let's go to my home lab here. And here's my servers. This is the last 7 days. Last 7 days right here. And here are all of my server CPU. And CPU spikes every night. And that spike is when Clam Antivirus is running in my home lab. So I have right here where I spike, right here where I spike, right here, right here, right here, right here, right here. So as a normal baseline for my system, between, this will be between like 4 a.m. and 9 a.m., I have high load on some of my systems. In fact, the system that stays high the longest is Hostbox, because it's my box that has a lot of my personal stuff on it, right? So that server stays the longest for its CPU, and then CPU and CPU. But then most of the time it's operating at about, 1.5% or no percentage for all of my servers. My servers are chilling, right? So this might be thought of as like baselining of my system. How does my system operate on a day-to-day basis? Like, what does it look like as my server comes into work and gets a cup of coffee and goes and sits at its desk? This is the normal day. But then if I came along and I ran some tests against my systems under high load to see what happened to their ability to still feed out their Samba shares or do whatever, that might be Clam Antivirus. Mama Benar, you've never heard of that? That's it's pretty common for Linux systems. I mean, if you're going to run an antivirus, it's pretty common. And it's owned by Cisco now, so Cisco owns it. There's also a version of it that used to be kind of popular called ClamWin AV, which was a Windows version. And it was just an open source alternative to other things. It's okay. It works okay. Some of it, the reason I got into using it was just to be PCI compliant. PCI will give you these weird requirements around you have to do these certain things. And not really with regard to rhyme or reason. So anyways, baselining and benchmarking. Often benchmarking is about stressing a subsystem to determine what it can do in the real world. In a perfect world, this is done prior to going live and will provide the data that will let us answer what is normal performance. Real quick, the difference between a load test and a stress test. In a load test, the system handles the load. In a stress test, something always breaks. Very important distinction from an engineering standpoint. Black Shell, I have multiple servers in my home, yes. I have a whole home lab system here and a bunch of different ways for you guys to access it from the Discord, yep. Yeah, I have a fair number of different servers here. These are all virtual machines inside of a XCP NG environment, yeah. Yep, all the servers you've seen me jumping into are my home lab, yep. Sometimes I burst stuff up to the cloud and do stuff in the cloud with you guys, but for the most part, it's all home stuff, yeah. All right. So let's talk about some benchmark methodology. I'm going to draw something out for you guys. Typically, we've got a plan phase, an experiment phase, and then an improve phase. What happened here? What the heck's going on here? That thing should be drawn all the way through. I don't know what happened there. But the plan phase is going to be goals identification. What do I want to learn from this? What do I want to make sure I understand about my system's behavior? What tools and metrics are we going to do? Are we going to look at the user space of the CPU or the system space or both? Are we going to keep track of how idle the system is or how much wait time or nice is happening? There's all kinds of things that we can track, but we need to identify that up front. And then we're going to plan and resource allocation. What servers are we going to do this against? And what is our main, at the end of this, what do we want to know? Right? That kind of stuff. Yeah. Well, Black Shell, yeah, I'm trying to, keep people doing system stuff. And the question was, do I have servers in the home? Yeah, I try to have servers in here so we could do it. And most of them are unpatched for 140 days. Not most of them, just some of them. The ones that you guys see. I have other ones that are part of the jail environment, and they might be up longer than that. Actually, I don't remember when we built them. Gosh, I don't have the memory I used to. I used to know everything, and now I don't remember anything. So we'll do what we can. All right. Then we get over to the experiment phase. We're going to define what we're doing exactly. Experiment execution, we'll run it in the environments that we need to, and then we'll get our results. Our results from any experiment should always be immutable. What does it mean to be immutable, guys? Somebody's not fudging the numbers. They're not adding a 1 or putting a 0.5 to make something look better or look less. Nope. Experiment results are immutable results, and we can then look at them all we want, but we cannot change them. Okay? You don't change results. Results are true whether they look good or look bad. You can spin it later, but the data should stay the same. The data are protected, right? Then our improve phase is we look at a report of what happened, right? We plan how to make it better. We shoot an azimuth towards a better goal, clean up the systems, rework how our connections happen. We do an improvement monitor, make sure that the things that we improve are better, and then we come back around and plan for the next part. All right? So these are the things that we do. All right. Here's some benchmark tools that we can do. So if you have two systems that have iPerf, you can start a server on one of them, and then you can start the client on the other, and you can talk between those two servers and see how much speed you can get. So I'll show you guys an example of this here in a second, but don't make noise server or put it in place underground. Black Shell, my servers sit directly behind me. You guys can't see them because I have a green screen up now, but they're not super loud. They're loud when they first come on, but they're not loud all the time. Yeah, and I bought them, over time, and I probably spent about $600 total on them over the years, so not a super break the bank in an engineering sense for sure. And for how much that I've gotten out of them and let other people use them, it's pretty good. Yeah, I have some old Dell, I think R720s and C610s or something like that. If you torture the data long enough, it will confess. All right. So let me give you guys an example of something that we did. We did this, so this was a few months back. I was working on a project, and I was on a call, actually, on my other laptop over here. And my boss messaged me, and he said, hey, Scott, I need to do some testing of throughput to 2 different links for one of our clients. Can you help me do that out of AWS? And I said, sure. So we went up to AWS, and we spun up a virtual machine in Linux, right? We spun up a virtual machine in Linux. It had to be on at least a large, like an MX large, because we needed a 1 gigabit per second link to make sure that we had a big enough link to talk to these machines. And then what we did was we set up a server on there for iPerf. We did an iPerf 3-S, and then we had the IP address of that server. Then my boss, he was on this other project that I didn't have access to, and he goes over to one of the servers. And what we wanted to do was we had two different links coming into the facility that they were working at, the data center, and they were 10 gig links from 2 different providers. We had a incumbent carrier, so we had an incumbent carrier in one and a different incumbent carrier on the second one so that we could have it. Yeah, Joseph, that's not that much over the course of like 5 or 6 years, right? That's not really that much. It's pocket change over time, right? Like the servers were probably a couple $100 each. It's not that much. But anyway, so what we did was my boss made sure that they were on one of their links. One of their links was the active link. And then he did a test up to the server that I had up in the cloud, right? So boom, he runs it. And he verifies that they're getting about 9.5 gigs per second, gigabits per second through this link. So we're good. Then we jump to the other link. And they had long suspected that their secondary link wasn't as good as the first. So we went to run the test, and we were only getting like 2.5 to 3 gigs. We were expecting 10. So we said, hold on a second. So he runs it with more and more of these connections. So you can actually spread out multiple connections. And we managed to push about 9.5 gigs over that second link, but we found some limitations. It seemed like they had maybe some stuff that was set on there to maybe scope each individual connection down. We don't know exactly why, but when we got on that secondary connection up around 30 threads going through, we got about 9.5 gigs, which is about what we expected. So then what we did was we tore this server down that was out in the cloud. We had it up for about 1 hour. He and I were working over lunch. I was on a call. He called me up. We spun the server up. We did this test between 2 different links. And what we were able to do was, for the cost of about, I think that server being on was about $5. It was on for 1 hour. It was like an MX large or something. We can go find out on Amazon calculator. But for less than $10 for sure, he and I, and then our time, which I was on lunch and he was just hanging. I think he was eating his lunch too. We got this server connection tested for our client like that with something up in the cloud. And it was super easy. It was super easy to do without losing network access on top. Is there a YouTube video about a couple of sysadmins transferring a Linux box with, oh, hold on. There is a YouTube about a couple of sysadmins. God, this thing just keeps scrolling. Powered by a UPS from one office across the city and bus and train and not lose the uptime. It's kind of funny. I've actually seen systems that are production systems up over 1,500 days. I have a system in one of my clusters. It just hit 1,000 days yesterday or today. It's been up 1,000 days. Gosh, it's on an old version of the kernel. It's air-gapped, so it's not as bad. Air-gapped systems are a little safer, but in zero trust, we don't trust those kind of things. So, trying to get them high IOPS with cards for cross-domain traffic wasn't cheap when I tried to look at it. Base guy, this server would not have been inexpensive to run all the time. Because you guys got to remember, there's about 730 hours in a month. So you multiply that by 5, that's $3,500, right? That's a lot of money. But just to do a quick rapid prototype, do our tests, and then close it down, $5. That server still actually sits there. When I turned it off, I just turned it off. I didn't terminate it. So if my boss ever was like, hey, Scott, you need to test that again for this other team. By the way, this isn't even a project I'm on. It's just something I help with because, they're my employer. So I go to other contracts if they need me to. And I can spin that machine up and tell those guys the IP that it gets. They can connect to it, make sure that the throughput's good, and then I can just give a thumbs up and tear the machine down. It's like that. Your server local, network, or public? Black Shell, I have servers that are exposed publicly for anybody to get into, and then I have what's called Bastion hosts to connect people into the back-end systems as well. So yeah, we have a lot of stuff. They wanted it as like a training environment, something like Cape Stack. Okay. Basically, I don't know what a Cape Stack is, but that's interesting. Yeah, if you can get throughput between two nodes. And guys, it's well documented, the sizes and the... you get different cards that get attached virtually to your machines inside of AWS, and based on the size of the machine, you get a different connected network card. So that is a useful thing to know, and you need to know it for Solutions Architect Pro, which me and Fisherman, when Fisherman's around, we're the two Solutions Architect Pros for AWS on our server. I don't know, some of the other guys might be as well, but I don't think they've ever identified themselves to us if they are. But Cyber Analytics Platform and Examination. Oh, okay. I have never played with that base guy. The Cyber Analytics Platform and Examination System. Never played with it, but that sounds interesting. Okay, so here's a benchmark with iPerf. Or sorry, that was iPerf 3. Now with Perf, you can just see what a system's doing. So with perfstat pwd, you can see what was happening when you ran the pwd command. What did it actually do? How much CPU did it utilize? How much time was elapsed? How many cycles did it use? All kinds of stuff from just looking at the statistics about a command. So you can see a lot about what an individual command does when it's run. And that's kind of useful. It's kind of valuable little thing. In this case, we just did a perfstat pwd against root. And there's all the things that happened with it. Yeah, perf can give you a lot of valuable information, especially of the startup of something and what it's doing. So there you go. All right, benchmark tool, stress and alternatives. So when we want to do that high watermark type stuff, stress is a really good tool. I like stress. It'll just dispatch hogs against, in this case, as though I had at least 2 CPUs, as long as I had like 2 disk devices, and then it's going to run for 2 minutes, right? Can this be used to check any other app? Suresh, this is kind of doing the system. Yeah, this will do any command that you run against it. strace is interesting. strace shows all the system calls going on. Yes, it's actually valuable. If stress is unavailable, because you can't always just put stress on a system, then you can stress it other ways. So in this case, this is DD, which is the disk duplicator. We're going to grab random bits off of the processor. We're going to do a block size of 1024, which is 1 meg, and do 2 gigs worth of data. And then we're going to bzip it with the highest level of zip, which is -9, and throw the output away. And that will take the system a certain amount of time. In this case, it took my system 5 minutes to do it. and that 5 minutes was all in user space. Very little system space, but it took a lot of processor time for this to work. Took about 5 minutes. Yeah, disk destroyer. Disk duplicator, right? Yeah, but disk destroyer. You can destroy disks with DD. You can absolutely destroy disks. You can write to the first 50, what is it, first 56 bytes or whatever it is. First 64 bytes, whatever that is. So the, yeah, you can keep things from booting with DD if you want. But there's some useful things with DD for reading and writing and speed testing and all those kind of things. I use it quite often for speed testing out to storage area networks to make sure that I'm getting a system level throughput aggregation like I expect. So I do that. I test things all the time. My testing, did I throw any? Yeah, so here's my DD for my reads and writes. This is what I was talking about. Now, I don't have it here. Let me check. Yeah, I do have it here. Okay, we'll do it here in a second. So our write speed, we can test how long it takes to write into somewhere. What's 512 bytes? Yeah, the 512 bytes for the master boot record. Fair. I thought it was smaller for some reason. I don't know. But here we're just writing to 5 files. We're just looping over and then seeing how long it took to write to some disk location. This is a local disk, so I expect it to be pretty fast. But we could write out to a Lustre file system or a GPFS and see what's our aggregate throughput according to the operating system. There's some information here about what's going on, so I'll let you guys read that for a second. Should do that for my busted Azure disk. Yeah, different dagger. You can see exactly how fast you're actually getting throughput to your systems. 100%. 100% something you can do. It's your system. It's like they gave you the keys to a jalopy and you like tried to start it and it started, but then you put your gas down and you only go like 5 miles an hour. They can tell you over in the Azure or AWS stuff that their systems achieve whatever performance, but you can go check, right? Go check. Who tells you can't check something that you're running? It's your system. All right, because you're never going to get faster than that. This is system level stuff. So if you have Java later that's going slow and you're like, well, that makes sense. I wasn't getting the system performance that you guys did all your numbers off of. Oh, it's half as fast as it was? Well, that's funny because I'm getting about half the speed I expected. Right? We're the system guys. Most of my stuff is I'm a system guy. I keep the systems nice and level so that whatever you build on top of it works at the speeds that you expect it to. So this is good. Jose, how's it going? Hopefully this stuff's useful to you on the YouTube side. All right, so these are the things that you might get. Then we read stuff. Can we read stuff back as fast as we expect to? In this case, we just read it out. We don't have to give the counter the block size. And it says right here, they're no longer needed because we're reading from what's already there. So we just read it in and we're getting whatever. Hopefully we expected to get about 392 megabytes per second as an aggregate to the file system, right? And if we're not, then, you know, any other calculations down the line are going to be slower than our expected benchmarks. So that's an important thing to understand. So we come down here, and this is something to look at then. This is actually a little table that I'll use on my servers. I'll gather all the information. This, by the way, guys, this right here directly relates back to this. I planned what I was going to do. I went and I did my definition of my experiment and wrote it out. I executed it and I got the results, and then I made a change, and then I went back through and I checked it again to make sure that it was faster or not. So watch right here. Gather current information, change table to practical benchmark baseline data to collect. So change this to whatever you need. In this case, what was my write optimization blocks? What was my write byte blocks? So what write did I write out? And then my disk rebalance took however long for 100 gigs. Then I made some change and improved the system in some way. Then I gathered new information, and now my system's slower, and my system's slower. But the disk rebalance took less time, so maybe that's what I wanted. Disk rebalance deals with, let's say you have a big blob of storage over here. You've got 100 terabytes, and then you add a new set of disks. So now you got 100 terabytes over here and 100 terabytes over here. But I want you to think about your access patterns to that data. All of your data was over here. Maybe you had 80 terabytes of data. So now you got 0 out of 100 terabytes full, and you've got 80 out of 100 over here. All previous reads ever come from over here because that's where all 80 terabytes are. And all new data goes to both. So new data being written is fast, sure, But old data reads never get a performance improvement because they're all over here. So what a rebalance of the file system is almost like you're sitting here with like some sand and a couple of buckets, and now you're pushing it all over. So now you've got, what happens with a rebalance is you'll have 40 terabytes of data in over here and 40 terabytes over here. So now reads are against all of the file system, and they get that improvement of improved bandwidth now. So you get that improved speed. They're not just seeking against a smaller number of disks in this first one. And that's the thing that's true. By the way, that's still true even if you have SSDs. You're like, stay away from magnetic disks. I'm just, it's all, there's no moving parts anymore for me. That's fine. You still have a theoretical bandwidth throughput. There's still only so much. And if you say, well, Scott, what is it? And I say, I don't know what it is for all systems, but I'll tell you what, if you give me a system that's on there, I will benchmark it now. Then we can make a change, and I will benchmark it after, and I will tell you how much better it is, even if it's only as a percentage, what we call a delta, right? If it's 50% better, if it's 5% better. But if we didn't measure it before, and if we didn't measure it after, all you're doing is going like this. You're not even like acknowledging the fact. You guys see what I'm saying? I'm always telling people, like, dealing with systems administration is bringing things up to the light so people can see it. Making sure that things are visible. When reading white papers, always look at the recommended, not required, as it never is enough, it seems. That's fair. Basic, I think that's fair advice. So this is how I will do things. I'll gather my information, make my plan to change, and then gather new information and verify the delta. Is it better? Is it faster where I expect it to be faster? Is it slower where I expect it to be slower? Right? And over here, this is the part of that as well. We plan. What do we want to experiment on? Define our experiment, gather our data, and then improve the thing, and then come back around. Okay? Always make the information. By the way, guys, this is all up on Discord. I just put it up there earlier, so if anybody needs it, Robodom, will you give everybody the Discord again? I appreciate it. All right, so these are all the things that we did. Got down here. All right, so now we'll do some troubleshooting. Some of you guys have been here for my troubleshooting stuff before. Some of you guys have had a fair amount of kind of troubleshooting stuff in our different systems. So we'll do some troubleshooting and look at how some of this stuff works, all right? But before we do that, I'm over 2 hours, so I'm going to take a break again. We're going to come back to troubleshooting, but let's go look at Ranger Dog. Ranger is still not on his bed. He must be partying somewhere. Look, the timer's still running. I'm going to put my hourglass up. Hold on. Hourglass. Dead. New. Okay. Quick break and stretch. I'm going to turn myself off. And then I will be back. We will be doing, not bubble shooting. We will be doing troubleshooting when we get back. Is that fair? All right. So stretch your legs. I will not start on that for 8 minutes. Take a break real quick. Anybody that needs it. Balancing sands. Yeah, I used to do a lot of balancing of sands back in my day. I'm like that old guy. Back in my day, Sonny. All right, I'll be right back. figured out why Ranger's not on his bed, guys. I figured out. Because they put his other bed by them where they're playing games. So Ranger's in there. That's why Ranger's not showing up. So that's why. In case anybody's wondering, where's Ranger at? All right, still taking a break. Yeah, they kidnapped Ranger, moved him in the other room. So, if you guys want to see what Ranger looks like, somebody has to follow. That's the only way to see Ranger. So if anybody's not following me on Twitch, that's the only way to do it. Because then you guys can see what Ranger looks like when he's unimpressed. Also, I'm getting some kind of emails, so that's always fun. Also, they look like they're having a good time down there. I went downstairs. The ladies are having fun still. They're playing games with my wife, so that's kind of good. Suresh, that doesn't come through. You might have to drop that on our Discord, whatever the link is, because I just see 3 dashes or 3 asterisks. All right, we're going to go to troubleshooting here in a minute. This will be system level troubleshooting. And this kind of troubleshooting can be used in anything. I learned this in the military, a lot of this. Yeah, Robodom, they haven't even gotten off of the... We had Indian food a few hours ago. They haven't even gotten off the table. They cleaned the table off and they're playing games. So yeah, I mean, if they're still watching a movie, I mean, I might have all night. I might be playing here all night. Oh, gotta fix the green screen back here. Look. When I get up, I move it. I like move it back a little bit, but I think it looks pretty good without the light on over there. So I think it's pretty good chroma. I'm a little messy, but that's okay. And I think my chair is black. That's good. All right. 2 more minutes. So if you guys got any questions about any of the stuff we've talked about so far, we can run through it real quick while we're getting back up here. But we started out with Linux Systems Administration. This is up in the Discord if anybody wants it. Presented to Prolug originally a couple years ago, and then I've just been kind of building on it as we go. We did administrative tasks. We talked about observe, benchmark, and tune systems. Then we talked about the utilization, saturation, and errors, what we call the use methodology. We're going to see that again later here too. Then we talked about a bunch of different tools, and I cleared off all my annotations when I saved it for you guys so you didn't have all my messy drawings. Talked about a bunch of tools. We talked about the big 4, CPU, memory, disk, and network, and how you find utilization, saturation, and errors in each of those. So we did that earlier. Suresh, there's actually a lot of ways to do that. Mostly that kind of stuff happens with logs. So then there's observability of the information of system. Then we talked about testing methodology, and I showed you guys a little bit about that. Then we did some benchmarking, and I talked about different tools and how we use them, how we gather information, make a change, gather information again. So shoot an azimuth, make a change, shoot another azimuth, see if we're going the right way. Okay? Okay. Oh, so here's Suresh. What I do is, somebody tells me there's something wrong with the system and maybe it's a new application. What I will do is I will go check everything about the system. Is the system not experiencing full utilization of CPU, memory, disk, or network while it's running, right? So I'll check those things. Is everything level on my boat, as it were? Then I will check logs. Are there library errors? Are there things happening when this application's trying to run? How is it crashing? And then I will tell them at the same time, especially if I'm on a call or something, because I used to support about 200 dev teams. So they were always putting apps on our servers. I would tell them, hey, you got to make sure that you're looking at your logs too, because on my logs, I'm just seeing the process starting and the process failing. I see nothing in between. So then for them, it may be, hey, it's time to go look at this. I look at, hey, during that time, did we ever hit a high watermark? Did we ever hit 100% utilization of memory, or did we start swapping disk, all kinds of these things. So, Suresh, there's no one answer, but it all comes down to that same stuff I'm showing you. I'm checking those things. I'm making sure that my server's still doing what it needs to do. And then those people are looking for errors. I'm also looking for errors because man, you could have network errors, you could have closed port errors, you could have, oh shoot, I forgot to turn off the firewall errors. There's all kinds of things that can happen. All kinds of things, right? Yeah, I mean, Suresh, that's kind of I spent a lot of my career doing that. So, all right. We'll reset that and we'll move that out of the way. So we'll do some troubleshooting. We'll talk about some of those things too. Basil said something about tiny PC. One uses a small NAS for a friend. Currently it randomly crashes. No kernel panics. Nothing in the logs when it happens. Something on idle. Sometimes a smaller high load. Is there a way to get some extended logs which aren't active by default? Basil, there's probably not, but one of the things you might want to do, if you suspect something is happening right before a crash, you could have SAR running. You could run a tool called ATOP, where ATOP will go and it'll keep track of everything that's running on the system and how much it's using. And it can be configurable to like every 5 seconds, and it'll write it off to a log. And then when your system crashes, you can come actually look at what happens with the crash. Because you're saying the system actually turns off, right? Yeah, so I would look, in my case, if that were me, I'd be looking in the, when you do your last more, you'll see the system reboot. And then I would be looking just before that in my varlog messages or varlog syslog, varlog auth or varlog secure, depending on what systems I'm on. And then I would be just looking for anything that is aberrant. And then the other things I would be doing, again, some tool like ATOP or something to get a slice of everything that was running at the time when the system broke. And those are the things that I would do typically. Because, yeah, once that data is gone, it's gone forever. If it's not in one of your normal logs, it's gone forever. So you have to kind of be watching it in real time. So if you have more info on that and want to drop it in the Discord, especially in like a home lab thing, somebody will try to take it apart for you. Or me later when I get time. So, troubleshooting. There's troubleshooting theories. There's a lot of them. My advice is do not try to learn all of them. There's no reason to learn all of them. There's a reason to learn one good one. So if this first one resonates with you, use it. If some of the other ones I use and do resonate with you, use them. Okay? There's different ways to do all this. Can you make playlists for your videos so we can learn from a sequence? Sandeep, I can probably try to do that. In fact, my goal around here, recently, my goal has just been to keep putting stuff out because people seem to be liking the YouTube stuff, so I've been doing more. But yeah, Sandeep, the question was, can I make a playlist for the videos? I am going to be making a individual, I won't even be on it, it'll just be me going through the labs, talking through the lab stuff. And there will be a playlist for that. It'll be every single lab that I've ever made, right? Over on Killer Coda. So those will be like Killer Coda identified labs. This stuff is more theory. A lot of this stuff is more theory. There's a lot less hands-on here. You can watch that stuff in pretty much any order you want. We've got a network primer. We've got a high-performance compute one. Every one of those is just... I'm trying to make these from like as beginner as they can up through... I'm calling it beginner through enterprise because I keep saying like being an expert is irrelevant. Like I know all kinds of guys that are experts that don't actually get anything built. They just sit around and talk theory and, you know, they're like college professors and stuff. And I have a good number of friends that are college professors. I'm a college professor myself. But what I'm saying is being an expert doesn't get anything built. You know, some of the most useless people I've met in my life were in Mensa. They're the smartest people around, but they just push lawnmowers all day because they can't deal with their tremendous intellect, their dizzying intellect, as we say from The Princess Bride, if you remember that. Okay, so anyways, yeah, learn a way to do it. So here's one. At the highest level, most troubleshooting follows this pattern of some way. Identify the problem and its symptoms. If you don't know even what the problem is, how are you ever going to solve it, right? Establish a theory of probable cause. There may even be multiple things in a row. Test your theory to determine which one is probably right. Reorder those things that could be causing it. And then establish a plan for resolving the problem. So of these things, this is how I'd fix this, how would I fix this, whatever. Implement the solution or escalate if you don't have the permissions to, right? Maybe you're a help desk person and you've identified something, but you've narrowed it down to these 4 servers out of 7. Okay, boom. Now you can hand that off because you don't have the root permission to do the other things you need. When you're ready... And when it's done, you verify that you have full functionality through whatever unit and smoke and whatever tests you have. Implement preventative measures so that that thing can't happen again. if it was something that could be stopped or prevented, and then document your findings, actions, and outcomes. These things are going to roll, and I'm going to show you guys a drawing that visualizes this as a piece of logic, okay? In fact, it's the next thing. So, this is that troubleshooting visualized. So hold on. There's 6 steps right here and a 7th step. These are all the steps right here. So let's go back one real quick. Identify the problem, establish a theory, test your theory, establish a plan, implement, verify, document. All of those things come over here. We start up here, identify the problem. We stop down here. This thing is almost a real flowchart. It's not a perfect flowchart. Perfect flowcharts are a little better than this, but this is still pretty good. Identify the problem and its symptoms. So we start. We gather all the information. We go and we run those commands. We look for utilization, saturation, and errors on our systems, right? We identify the symptoms. Well, utilization was really high. We started to see a queue form. We started to see errors. Okay, good. Question the obvious. I'm always asking, well, can this server actually see that server? Ping it by name. Oh, we're not resolving the name anymore. Is DNS down? I'm asking questions the entire time. In fact, my mind tends to be racing as I'm doing this. But I'm questioning the obvious, right? Can the server do certain things? And then I'm going and putting those off to the side and going, wow, that's not working. So that would cascade to these other things, right? As we question the obvious, we follow the OSI model. The OSI model is a 7-layer model that we use to break down where things happen in systems. I have a whole primer on networking that's like 3 hours on that stuff. Skull Crusher said the hardest crash I had to detect was a RAM stick that had a resistor broken off, and it took 3 passes of memtest 86 to detect it. First 2 passes were fine. Oh wow, yeah, that's terrible. Oh no, I lost my thing. Hold on a second, guys. Hold on. I leaned back too far to scratch my arm. I've lost it. I've lost it, guys. My whole screen went down. This is funny. Oh no, I can't get my screen back up, guys. Hold on. That's funny. I'm going to turn this leg so it doesn't push back as far. Turn this leg so it stands up better. Parts fell off of it. For some of you guys, that's something you've seen before a lot anyways, because my home, I normally don't have a green screen. I've only had a green screen for like a week now. So some of you guys have seen my home a billion times, so it doesn't really matter. Yeah, cut. Hold on, is it better? That's better. Over here is not. I leaned back too far in my chair. What I need to do is I might fix the green screen across. Yeah. And then I can put it further back from me, but that's fine. That's fine. You guys don't pay attention to anything behind the screen over there. Troubleshooting. What did we do? We leaned back too far. Don't do that crap. Okay. Follow the OSI model. Test your guess. You made some guesses. You made some assumptions. Are they confirmed? No. Do you give up? Escalate to somebody else and stop. If you don't give up, come back through and keep spinning. Follow the OSI model. Look for the next thing that's broken. Test your guess. Confirm yes or no. If you did confirm that your guess is what's broken, come down and start planning your steps to fix the problem, right? Then we come down here, we fix the problem. We actually implement the change or whatever. What happened? What happened? The screen. Yeah, Rodan, I think the green screen gives you guys more ability to see what's going on. So I think it lets you guys focus on me and not what's going on in the background. So that's fine. All right. It does look, yeah, so Robodom, I turned this light off over here. So now, yeah, the chroma doesn't happen nearly as much anymore. Yeah, it looks a lot better. There's a little bit still, but it's not super bad. Okay. So we go through, and this is troubleshooting, guys. This is what we do. We don't always know what's going on. We don't always have all the answers, but we can have some starting point, gather information, and keep moving through things in a reasonable way. If you've ever been on a call late at night trying to fix things, you will find that they'll panic easily. And if you just keep track of what you're doing, and people are like, what's your status? And you're like, well, what I'm doing is I'm testing, I'm in the gathering information phase still. I've gathered all this. I know these things are still working. So what I'm doing is narrowing it down to this. And most of the time people be like, okay, phew, Linux guy is on it. Linux guy fixes everything. Because I'll tell you guys, and you think I'm kidding, and you might think I'm trying to humble brag, but I'm not humble bragging. I'm bragging. I'm just kidding. But it's true. When they find out that you know how to fix things, they will bring you in on every call. I get brought in on every call, even if it's unrelated to what I do. And you say, really? Yeah, because the Linux guy fixes everything. The Linux engineer literally had to fix everything to even get his job as a Linux engineer. So he will be good on the networking and the firewall stuff. And people think you're good at fixing anything because you just follow these things and ask questions. I've been on calls where managers that I do not consider terribly technical managers were really, really good at questioning the obvious. I've known managers that just really were good at digging in on, hey, you said that this was like this, but why is it not like that? And then people are like, oh, shoot, that is the answer. And they're not even technical managers. They're just managers that were really good at walking through a process like this. So you can really, guys, you can get really good at this thing here and make yourself exceedingly valuable to the business. Even though it doesn't matter what the problem is. You know how to solve problems. Does that kind of make sense? By the way, you guys don't have to screenshot this. This is up in the Discord. You can go grab this as a whole PowerPoint if you want it. All right. So there's that. Then we come down here to test troubleshooting methodologies. There's other methodologies that are useful to understand when you're troubleshooting things. And all methodologies should have a starting point, some type of process that you follow so you always know where you're at, and then an ending point. So what I just showed you had a starting point and two ending points. One ending point was you gave up and tossed it up to somebody higher, and the other one was you found the solution. But you could move through all of those things and always be able to tell somebody where you're at. There was a guy named Deming, Edwards Deming. He helped rebuild Japan after World War II. And he had this saying, he had these 12 Deming principles. But one of his principles that I really loved, I learned about him in college in one of my master's programs. He said, if you can't describe everything you do as a process, you don't know what you're doing. And I really like that. If you can't say stop right now, just stop. Where are you at in your process? You don't know what you're doing. And I 100% agree with him. Whether we were talking about I used to work with weapons systems in the Army. I was an infantry guy. And I tell people all the time, if you understand how your system works, it's super easy to troubleshoot it. But if you just say random things like, oh, it was a double feed, that doesn't make any sense and it doesn't help solve what actually happened to your weapon system. Same thing here. If you don't understand how a system works, it's harder to troubleshoot. In fact, we're going to get to that here in a second. But for methodologies, all methodologies have a starting point, some process you're walking through, and then an ending point to show that you're completed, right? Okay. That's funny. When my green screen broke, I lost half my viewers on YouTube. People were like, this is a shit show. I don't want to be here anymore. I'm just kidding. I don't know. I might have just not been looking. Oh, now they're back because I mentioned them. Now there's more viewers. I'm just kidding. Okay, here's the ABCs of investigation. Assume nothing, believe no one, check everything. Guys, I have saved myself so much trouble as an engineer. I do not assume anything. If I SSH to a box, okay, fair. I assume the box is on. But I'll tell you what, I've SSH to a server by name and been in a different server, and I'm like, I'm sure I just SSH to this node, and I am in this node. There is something wrong here. DNS is busted. The node is busted. Now I got to go find what's actually busted, but I assume nothing. And then this one is true. Gosh, guys, this has saved me literally hundreds of hours if I had to guess over my career. Believe no one. I have come on calls, guys. I've gotten on calls and people are like, the server's down, the server's down. The Linux guy's here. Oh God, the server's down. Whatever server's down. They'll tell me the name of the server. I'll go jump into it and I'll be like, the server's up. What are you talking about? And they're like, oh, no, sorry. The service is down. I said the service is down. And you're like, no, you definitely told me that the server was down. And I got here 20 minutes late. Like, you guys finally called me out. You've been assuming a server's down? It's like the, you guys ever see The Water Boy? Where he's like, I said Joe Montana, not Joe Montana. He's like, Joe Montana's a quarterback. He's like, I haven't seen tackling that good since Joe Montana. And he's like, no, Joe Montana was a quarterback. And he's like, I said Joe Montana. That's what I feel like sometimes. My point is, don't believe anybody. Come in the call and test anything that's told to you, because I have saved myself so many hours by just going, wait a minute, hold on. Homer, are you just holding on to the can? Have you guys ever seen this scene? They're about to cut Homer's hands off, his arms off, because he's holding on to the cans. He's stuck between two vending machines, and they're about to cut his arms off, and they go, wait a minute, Homer, are you just holding on to the can? And he goes, your point being? Homer, you almost had your arms fucking cut off. All right, I'll be good. But the point is, that's one of my favorite things. Like, we're assuming things, but I don't believe anybody. And then check everything. They tell you the server was down. They tell you the server rebooted. Go to the server. Do an uptime on it. Go to the server. See if it can ping out to Google. Go to the server and see if it's got the proper name and the right kernel and all the things that you expect it to have as a proper member of your network. Now, I told you guys this, like, I maintain a lot of servers and I keep them all very clean. The reason I keep my servers very clean is if somebody comes along, you know, and it's me late at night, and they take a little thing and they start... Yep, no dust on the server. It's very easy to see things that are on the wrong kernel or not connected to the right NFS share, or anything that's aberrant is very easy to find because I keep all my stuff clean. And people are like, oh, you know, this guy's a fanatic. That's a good part of being an engineer, is being a nut job, keeping all your shit clean. Because we have the tools to do it. Ansible's the easiest tool in the world to keep everything all organized, right? So anyways. All right. So systems engineer trait. Yeah. It's a madness, but I tell people, because I went to, so years ago, because I spent some time in Iraq as an infantry guy, so I had to go to a medical thing to get a diagnosis. And the guy was like, hey, do you want me to diagnose you as ADHD? You've got ADHD. He's like, I talked to you for an hour. You got ADHD, all the symptoms and stuff. And I said, you don't have to diagnose me with it. He goes, really? And I go, I made it, I think I was like 39 at the time. I said, I made it 39. I just ride the lightning. It just makes me a better engineer, I think. And he's like, all right. Well. He's like, yeah, some people don't want to know. But he goes, just so you know, you've got it. And I was like, yeah, fair enough. But I don't need the diagnosis. I still in the doc. That's fine. He probably put it somewhere. It's probably in my medical record, but I didn't need it for what I needed for the military. So I told him not to worry about it. Anyways, all right. So let's go through some other troubleshooting methodologies. Enough of my madness. Let's go with logical methodologies. If we were going to create, like I said, create a problem statement, look through your things, what makes you think there's a performance problem? I have walked in, I've had teachers tell me this over the years. I've had other people. Well, the system's acting funny. I can't do anything with funny. Is it going slower than you expect? Is it like noticeably taking time? That's something that we can measure. Now, they don't have to be like overly pedantic about how they tell you something, like they're giving you the exact terminology, but a system being funny is not the same as like a system not outputting the proper values when we run it, right? There's different levels to this. So, what makes you think there's a performance problem? Do we have previous data? Has the system ever performed well? Do you have a baseline reference? Are we just shooting from the cuff? Yeah, it doesn't work is better than it's acting funny to me. It doesn't work at least gives me a frame of reference, but my next question is, has it ever worked? Right? Is this a brand new system just out the gate? Or is it something that's been existing for 5 years? I'm going to go different ways based on that answer, right? Has it changed recently? Was there a software update? Did hardware get fixed or changed out? Was there a new data set loaded to it? Any of you guys ever turned a movie off because you can't suspend disbelief anymore? You guys know what it means to suspend disbelief? It means you know something's not possible, but you still watch the movie. Anybody here ever seen something like that? I'm not talking like you're watching The Lord of the Rings and he puts a ring on and you're like, a ring can't make you disappear. That's magic. That's one thing. I'm going to tell you guys a story. Yeah, it's suspending disbelief is the idea that you stop something and you're like, all right, it's for the movie. Well, I'm going to tell you something that I could not suspend disbelief, and I've turned this movie off, and to this day, I've still never finished this movie. Part of being good at tech is being able to communicate with different types of users. The better you can communicate, the more data points you have to troubleshoot. That's fair, Lance. I agree with that. Lance said that, yeah, being able to communicate is important. I 100% agree with that. In fact, I very rarely talk on meetings. In fact, if anybody finds me heated in a meeting or like talking a lot, it tends to be because I don't like what else is going on, right? Hold on, I'm going to tell you guys about this movie I watched. Does anybody remember? So the old RoboCop was fine, but anybody seen the new RoboCop movie? When I say new, I still think it's about 10 years old. I could look it up, but somebody here could probably tell me. How long ago did the new RoboCop movie come out? The newer one. I don't think they made a second one of it. But there's a scene in that movie that I could not suspend disbelief on, and I turned it off. I did not watch any further than about halfway through that movie. Hold on. 2014 Robodom, thank you. When I say right here, what's changed recently? Load data set. So Mama Benar, I'm going to tell you why I turned it off. There's a scene in that movie. They're about ready to roll. They're taking RoboCop. They're standing him up and walking him out to go see everybody. They are taking him production live. They're taking him live. He was in test. They're bringing him live. And this engineer that built him, this medical doctor, engineer, brilliant guy, said, right before I bring him live, I'm going to load him up with petabytes of data and change the system that's working. And I said, I literally can't suspend disbelief. This guy was smart enough to make this computer, this guy, but he's so fucking dumb that he's going to make a change in production right as he goes live. I can't do it. No engineer on planet Earth would ever do that. So anyways, that's why I've never seen the end of that movie. But anyways, my point is, what's changed recently? If you load new data sets up or you change the back-end database schema and you don't change the front-end code at the same time, you are going to have problems in your database, and you're going to have problems in accessing and all these kind of things. So anyways, that's something to think about. I've never finished that RoboCop movie. What's causing the load? Is it a process ID, some specific user, some IP address coming in for traffic? Yeah, who would patch as they're walking their robot out? It's absolute insanity to me. Like, I know they had to do it for the movie so that he would like flip out and like look around and like not be able to handle all the loaded data, but that's exactly what would happen to any engineering system if you did a change right as you rolled out to production. It doesn't make any sense. Guys, no sense is made there. All right. I'm missing some stuff. Base says, okay, till you go way off task on some other tangent. Yeah, so Base Guy, we talk about shaving a yak or yak shaving, if you guys have ever heard of that. It's the idea that I try to do this thing, and then I go over here, and then I go over here, and I never get the thing done that I need to. Did he catch the bad guy, Robodom? I never managed to finish that movie. All right, what's the load? Is it IOPS? So is it like throughput, that's input, output, process per second? Is it load average against your processor? Is it latency on a connection somewhere else? Maybe you're having slow API calls. Is it throughput because you're maxing out the actual theoretical throughput of what you know that your network can handle? What's causing the load? And are you hitting the full utilization, starting to saturate and starting to get errors from oversaturation? The problems always kind of go into these same different things as we break them down. Build it, ship it, patch it later, maybe. Yeah, that would have been smarter in that movie than loading up the guy with data literally as he was walking out. Robodom, I might have finished it. I might be lying to you guys. I don't remember, but I do remember that I've turned it off right there and just been like, I can't suspend that kind of disbelief. That would be like if Frodo just walked into Mordor and was like, here's the ring, guys. I was carrying it for you. It wouldn't make any sense to the rest of the movie. All right. How is the load changing over time? Are we experiencing high load every night when something happens, but now we're just happening to go a little bit higher and it's actually causing a problem? That's a common thing. I was showing you guys this earlier. If these devices do go 5% higher, this one's at 96.6%. If it goes a little bit higher and crashes, well, then I know that there's something else that was added in there probably over all these other years of it running just fine. And then I maybe have to go figure out what's going on there, right? This is something like, historical data is awesome for analytics, right? What did happen in our systems, right? Okay, so troubleshooting methodologies. This is the same thing we talked about earlier. Utilization, saturation errors. We're always asking that. We're always asking that about our systems. How utilized are they? How saturated, and is the line forming? And then our errors starting. Fun when you're watching a movie and start yelling at it. Yeah, Skull Crusher, fair. All right. Stepping through the OSI model. So I'm not going to go deep into the OSI model right now. We have a whole thing on that up on YouTube and over on the Twitch side. Suresh, yeah, go get some fish. You're always welcome to hang out. If we're not still around, I'll probably still be on. But if I wasn't on, you're welcome to watch this stuff later, guys. How do you break a system FIPS? Base guy asked about breaking a system's FIPS. Well, so I build systems that have FIPS in them, so I could just break it by not being compliant. But breaking into systems that are already like that, I mean, you're probably going to have to spend some time compromising users typically at that point, right? It's easier to compromise users than it is systems in most cases. So, and that's, by the way, that's played out in most cyber attacks around the world in general. So anyways, let's talk about this. People have silly little anagrams and ways to remember this. All people seem to need data processing. Please do not throw sausage pizza away. Please do not touch Steve's pet alligator. There's a whole bunch of dumb ones like that, right? But I'm going to tell you guys, instead of doing that, just learn the layers that actually matter to you, right? Transport layer. This is where we're either doing TCP or UDP, and then we are either doing connection-oriented or connectionless, and then that's going to affect everything down below, right? Network layer, that's where our IP addressing happens and where we have packetization, and then ICMP occurs here, and we have routing and all these different things going on here, right? Then when we feed down into here, we get frames and super frames and jumbo frames, and we move data around only to the next hop right here. The data link really only cares about the next hop between devices. So this is going to be your MAC addresses and non-logical. But then you got your spanning tree protocols and other things down here. And then the physical media is any way that we move the data. The bits, the ones and zeros. Is it radio? Is it electrical? Is it photons across a fiber optic? Excuse me. Is it photons across fiber optic? What is our channel speed, our bandwidth, our distance? This is all the stuff that's standard for all of these. Whenever I tell you guys about things like this, we talk about what's called a protocol. Protocol is the protocol is the definition of a protocol, is a set of rules that govern communication. So when we talk about application down through physical layer, and then we send it over to the other side, and then it goes back up, as long as everything's following the same communication model, everything's going to work. If I start going like this, you guys can't hear me more than this, isn't very good. That's not a very good communication model anymore. I changed the rules. I went too low for you guys to hear. I went down to like ASMR type zone, right? And my point in showing you guys all this is to say that if you understand this model, it will help you to troubleshoot things. I used to know network engineers, and some of you are going to think I'm exaggerating, but I am not exaggerating. I've seen this happen. They get a call from somebody. They're network engineers, so they're typically up to about here, but they're right here. And they get a call from somebody and they say, I can't reach this system. And they pull up a prompt on their desktop and they ping that system and they hang up the phone. You guys think I'm kidding, but in the early 2000s, that was a thing. Probably even earlier than that too. Because they could ping the device. It was up. It was routable. Like, it was fine. And then like some people would maybe SSH over to the box and then ping out and then to hang up on them. But the point is, I knew engineers that would do that. Somebody would call them up and say, this device is down. They would ping it, and they would know that it was up to at least here where they cared about it, and they would hang up the phone. Nowadays, you'd probably get in a little trouble for that. But I'm just telling you, like, back then, like when it was wild, wild west of systems world, that was probably more common. But also, I mean, some people don't like when you waste their time, right? Like, you should have pinged that box. You should have seen it was still up. I don't have to go to a data center and plug it in. It's on. It's accepting ping, right? It's traversing. Now, if something else is occupying that IP space, we got a different issue. But the point is, for the most part, it's good. So stepping through the OSI model, big part of understanding troubleshooting. I've got a whole thing on that, so we're not going to deal with that too much. This one right here deals with understanding. This is like being a doctor. Now, a doctor may not know you personally. You walk into their doctor's office for the first time, but they know people. They understand people's systems, so they look at the symptoms, the way that a throat is supposed to look, and the way that an ear is supposed to look, and the way that a system is supposed to look, and the uptime and the load. And over time, you start to look at systems, and they're always the same. And then you start to look at the symptoms. Well, this system doesn't have as much memory as other systems, and then we start to try to find what is probably causing this server to go high memory load. Well, it looks like it's missing 128 gigs of RAM. Is there a bad RAM disk? And then we start going and looking, and we find out that, yeah, one of the slots of RAM is bad. Did you guys know a server can run just fine with bad RAM and also with bad disks. Most servers will just keep on chugging along. Throw errors every now and then, break all kinds of code running on them, but they're still chugging along. They very rarely just crash. Servers are pretty damn resilient. All people seem to need data processing. Yeah, that's a very common one. All people seem to need data processing. Yep. And then they treat it. And then if that doesn't work, they go back up and look at the symptoms again and go, nah, your throat's still red. Pouring a whole bunch of cough syrup down there didn't help. Well, guess we'll go to antibiotics. And they just go down the list. If any of you guys have ever worked with cancer treatments, this is exactly what they do. The very first thing they do is they say, all right, you're pretty healthy and it's only stage 1. We're just going to give you some of this for 6 months. Oh, that didn't kill you and the cancer didn't kill you? All right, we'll go to this because that didn't work. That's actually how cancer treatment works. And if you guys didn't know that, that's kind of wild. They just try the next thing down the list. That's why companies, like I used to work for a company called Caris Life Sciences, and what they did, it's CARIS. But anyways, they're still in Phoenix. They're still a good company. They worked to look at your genes. They had like a 600 gene panel they would run on you, and then they would say, you know what, those first 3 aren't going to be any good for you. Let's just skip those. Go to this type of treatment that works well with people that absorb protein the way that your cells do, and it's an experimental treatment. But those other ones we know don't work for people with your. And they were very highly successful. I was working for them back in like 2014 through 2016, so that was a long time ago. But they're really good. They're a really good organization for that kind of stuff. They're still kicking. I got a buddy that still works for them. But yeah, so symptom diagnosis solution. Look at the symptoms. But this understanding here is you have to understand systems well. You don't need to know those systems well, but you have to understand normal systems well. Okay, that's the one where we need to be there to boot. Okay. Systems thinking. This one right here, I think, requires you to know the most about the systems that you're looking at. This is systems thinking is the process of analyzing all interdependent components that comprise a system. So, look at all the pieces and how they connect. What is the system supposed to do? How does data flow in this system? What are the systems or devices between the device and the network and the device attempting to communicate? Where is the logical thing broken? What other devices are attempting to communicate with the same systems? Are they still working and only this one is not? These kind of things. Has the system changed the environment within it operates? Has somebody come in and dropped a bunch of firewalls? And this happened at AAA years ago. For PCI compliance, they started locking down firewalls. And the firewall team went and took all the changes that had ever been requested for all of the servers, and they put those in as allowed rules. But when they locked off our firewalls, they stopped all kinds of other things that had been working in the company. And we had to spend months re-requesting things that had been part of the original system builds but just hadn't been captured. And we had to go back through and punch all these holes in these firewalls because the firewalls weren't coming out. They were there and they were going to be locked down. We had a permissive trust model everywhere. And we were going to much more of a zero trust model. So you had to have a reason to talk to some other device. And has the system been physically moved recently? That's huge. Has the system rebooted recently is big too. But systems thinking is this idea that I understand there's a logical web front end. There's a web presentation tier. There's an application logic tier that it gets fed back to. And then from there we go back to our data tier. And then we work through these different tiers to understand how data flows. And that takes a certain amount of expertise in that particular system. So this is one of the harder ones to get to. But look, I'm telling you guys, use whatever tool that works for you for troubleshooting, right? To walk through these things. All right. Okay, so these are all the troubleshooting methods that I have in here. It's troubleshooting theory. This is the general theory. This is the general way that we walk through that. Identify the problems and symptoms. Establish a theory of probable cause. Test your theory. Establish a plan. Implement it. Verify or go all the way back up and go to the next one. If it works, was it preventable? Take the preventative action. Come over here, document your findings, and stop. Okay, we walked through these, right? All these different things that exist. By the way, this is again up in the Discord now, if you guys need it. FMEA, failure modes and effects analysis. This is much more of a what could go wrong. Like we're sitting around ideating all the things that can go wrong in a system. And I'm actually going to show you guys some real problems here that I actually experienced as an engineer. I was the platform engineering lead for AAA for many years. We had about 5,000 servers. About 1,500 at any given time were Linux, and about 3,500 at any given time were Windows. And sometimes those numbers fluctuated, but about 5,000 servers, let's say. And this is a government technique that's been around military, U.S. military and government technique from the 1950s. But it's a systematic process to look at what could go wrong, what impact could it have if it does happen, what's the likelihood of it occurring in a natural state, and then what's our ability to detect and react to it if it happens. And from these 4 questions, we can go through this process of, there's 2 real steps. We round up all the failures that we know of or can imagine, and we assign scores to them based on some of these things. Okay? So let's look at it real quick. This is what, actually, do I have, yeah, okay. This is round up all the possible failures. This is a real environment that I really worked in. I'm going to explain to you what each of these mean. But imagine for yourself that you've got a team of engineers, my platform engineering team, and you didn't have to come to us and request servers from us. You had a tool called VRA, vRealize, I forget what the A stands for. VRO is the vRealize Orchestrator, but VRA is a different tool that does like a catalog for VMware, right? It's a VMware product. And what it allowed us to do was I could build a bunch of menu items, and you on your dev team, that's not one of us Linux engineers, you could go in and say, well, I have some capacity. I'm going to push this button right here, and it's going to it's almost like a little gumball machine. It's going to pop out a little Linux server for you. That Linux server is going to have a name, either non-prod or prod, whatever you needed. It's going to be tuned already to your Active Directory. It's going to have all the component pieces that it needs to be part of our system. It's going to have our backups, our network, our Active Directory connectors. It's going to have everything configured on it. And I built all the Ansible that did all the individual plays for that. But there were things that could go wrong. And let's look at those things that could go wrong. So this was failure modes and effect analysis for things that could go wrong with my server builds, right? Here it is, server builds. The initial image, so inside of ESXi, you have these libraries, backend data stores of stored VMDKs, right? Your virtual machine disks. And we had gold images that were out there stored, and those were all connected over backend fiber channel links to all of the ESXi machines. If somebody for some reason hit a button and wanted to pop out one of those little servers, but when they hit that button, the ESXi server that it tried to place that server on didn't have access down to that storage, it would break. So that was bad. That was the failure mode, was the image wasn't there. The cause, backend storage may be offline. And how did we have a control for it? We would monitor the system with vSphere. So we would monitor the vSphere systems to make sure that they had access to that at all times. And there would be just like an alert that came up for our bridge team or whatever if something happened. Okay? There's an automation job, kickoff, that fails. And that job is, so vRealize Orchestrator is running all the stuff in the background, and it's going and maybe hitting our Ansible playbooks. But what if its credentials are out of date? Because every 60 or 90 days, somebody in in our identity and access management team decided that even service accounts have to have credentials rotate. It's annoying. It's asinine, but okay. So now our VRO, our vRealize system credentials are out of date. They can't kick off the jobs and build servers anymore. How do we check that? We have a daily process that kicks off at 4 a.m. every morning, and if that starts failing on any given day, then we just go and fix, we do the process real quick to fix it, and then we don't have to worry about it for 90 more days or whatever, right? Set up a calendar so that doesn't happen anymore. But the point is, we can do a daily build process every day and build all of our types of servers, all of our Linux boxes, all of our Windows servers, and we would do that every morning. We'd build like 12 system types, and we would just get a report that said, good, all the servers built. Good. Guess what I did then? I just sat around and twiddled my thumb like this because that was all I had to do. How about this one? There were different agents that could break. There were agents that got put on server. There was an Avamar agent and a backup agent and a networking agent, and later on there was Falcon Strike and whatever these different agents are for antivirus and stuff. And maybe the version of the agent or the credentials were out of date, or we needed to push them to we had a thing where we had to push them to like a different endpoint. So I ended up having to update a bunch of servers with Ansible, and then on the new builds, we just had to go in and change how it worked or whatever. Hey, Mocha Tech Plays, thanks for the raid. We have 8 people hopping in. Hopefully this stuff's useful to you guys. We are going through systems administration, Linux systems administration, right? Yeah, there's Ranger, in case anybody wanted to see Ranger Dog. There he is. So yeah, hey, thanks for the raid. Hopefully this stuff's useful to you guys. Were you guys doing anything fun over there? Also, what am I missing on the YouTube side? What tasks are given to new hires as Linux engineers or admins? Do company let you shadow first on seniors? Yeah, Lexi, there's a lot of shadowing of Linux engineers at first. Also, there's a thing that happens. Hold on. Let me open a file for you guys real quick. The question was, what happens in Linux systems administration? So this is a thing that I put together for this. Oh, geez. For this project when we were originally doing this. This tends to be what you do as a systems engineer and a systems administrator. As you first start, sysadmins tend to start over here. They're in the operation and the optimize phase. I probably should add this to my little presentation here, kind of what you do. But as you start, you're in operations. You do keep the lights on, and you do network operations center and security operations center and help desk, and you run these different types of things, right? Then do you optimize the system and try to make it better? Because that's a big part of moving over into the cooler project work, which is the prepare, plan, design, and implement phase. This is a model that comes from Cisco. Prepare, plan, design, implement, operate, and optimize. These are the things that systems engineers and administrators do all the time right here. So I'll add this as part of that discussion, because I have all these other things over here too that we talk about, troubleshooting and questions around baselining and Linux skills and all that stuff. So we can talk about that if we get through all this. But we're talking right now about failure modes and effects analysis, which is a actual technique that we use to find things. So we got down here, the agent credentials were out of date. Well, how would we find that? Well, in our daily builds, we'll see if things were broken. So that was one of our controls to make sure that that server build thing didn't break. And then this last one, this one was insidious. I hated this. Final build checks would just fail. You'd get to the end, and instead of the little thing coming all the way down as like a little gumball for the people, it would just stop. And then it would be like error. And you'd be like, damn it. So the cause was unknown. We didn't have a good cause of what did this. And our controls were none. So it was terrible. So let's take this roundup of all these things that we kind of have seen and understood, and let's turn it into numbers, because if any of these things are going to be useful, they have to be quantified in some way, right? So let's come down here. And in a failure modes and effects analysis, we have, hold on real quick. Did I miss those on any others? Hold on. I want to pull this off real quick. Hold on. Hold on real quick. I got to fix this real quick. All right. Just wanted to clean that up a little bit. I should probably go clean it up on the other one too. I'll clean it up on the other one too later. But all right, so we're back here. Hold on. Okay. You guys should be able to hear me again. Good? Okay, yeah. So severity, probability, detection equals what's called the risk priority number. Now these numbers are always between 0 and 10. 1 and 10. They can't be 0, because if they were 0, you would make this risk priority number zeroed, right? You can't 0. Thanks for that. I'll need to rewatch previous live streams. Appreciate it. Yeah. Well, Alexi, we have a lot of content and a lot of stuff up on our Discord is a good place to start for most people. Okay, so anything between 1 and 10, the higher number is worse. So we go back to the same thing. Initial image unavailable. Customer impact pretty low. Likelihood really low. Detect and react. We had a decent detect and react, but not great. So our risk priority number for that was 10. By the way, very astutely, you might note the risk priority number can be a number between 1 and the number 1,000, right? Because 10, 10, 10 would be 1,000, right? Automation job kickoff fails. Customer impact a little higher. Likelihood a little higher. Detect and react, we had a pretty good plan for that, 30. Agent register to server backend fails. This one was bad. Customer impact pretty high, because sometimes these would get through. Likelihood, kind of high. We didn't have a good detect and react for this. So this one was a massive problem for us as far as the other problems go. And then final build checks fail. This didn't happen very often, but it was a huge impact when it did. But we had a pretty good, I don't remember, I think we might have had a good way to detect and react to this one maybe. Oh yeah, because we got an alert. So then we would just build a new one for them and send them the info. So yeah, so this one wasn't too bad. But this one was, I forgot, this was the insidious one we wouldn't see this, and then they just would be like, well, our server isn't backing up, or we would find out later from some other process that their server wasn't backing up. So this one was super annoying, or it would have an old version of the agent or something. Weird things would happen. And this one was one that I ended up spending more time on. But this failure modes and effects analysis gives me which ones I want to focus my time on. It's a triage, right? Does everybody know what triage is? Triage is you go to 3 people on the battlefield. One person's been shot in the shoulder and has a pressure dressing on it. One person's missing an arm, and one person has a sucking chest wound. And you're like, well, which one do I work on? Well, if they've tourniqueted the one with the arm off, then you got to fix the sucking chest wound. Anyways, all right. ABCs, right? All right, we don't need to worry about that. But a few other notes on troubleshooting: avoid talking about your feelings. I feel it feels slower than normal. That's an anti-methodology. That's not really important. That's an irrelevant thing to talk about. We call that an anti-methodology. Other anti-methodologies: the blind man, just flipping things. That's not good. Spotlighting. I know how to use this one tool, so I just always use Uptime, and I never go and use any of those other tools that we were talking about. That's a problem too. You don't want to be somebody that gets stuck in only using tools you're familiar with. You have to understand different paths you can take and then go read about the tools and figure them out. And you don't want to be figuring out how to use a tool when it's a live problem. You want to know how to use your tools before that. And then you don't want to blame somebody else. I used to always tell my engineers, do not get on a call and blame networking. Networking gets blamed all the time. We can blame them later, but don't blame them at the start. And the way I blame people is I just pull them aside and say, hey, you know what, this doesn't look right. I've got this and I've got that, and those servers are still talking, but this one's not. Is there something, I'm not really blaming them. I'm just asking them, can you verify this? And then they go, oh, yeah, that is busted. And then they figure it out, right? A guy told me the network was funny. Yeah, I tell people all the time, what do you mean it's funny? It's telling jokes? It's irrelevant if it's funny. All right, questions. Drop them in chat or Discord. So that was our talk on, for people that weren't here at the beginning, that was our talk on Linux systems administration, right? So that is that. What else do we have here? We've got Ranger is not there because the wife took him over by her friends, and they're over there hanging out with that. What else did we have? We have our security primer. We're not going to go over the security primer right now, but we do have security stuff for people that want to get into the ISC squared kind of domain of servers and that kind of stuff. And then we did have this Linux stuff open earlier because we were talking about monitoring, and we were going to do some monitoring telemetry, but we didn't get around to it. It's not that big of a deal. I think we're probably good. Let me see this here. This one need to be fixed a little. Do we need it more forward, more back? I'll have to play with that one because that one's not doing as well as it should on the chroma over on this side. So, all right. I'm looking for an exam soon. It's free of cost. You guys can join if interested. Nice. What exam are you talking about? A Sondip 55 or 555. Nah, Robedom, I don't care that much about it. I just want it to kind of look clean so it doesn't distract people. What else do we have? I got a bunch of college stuff I got to do. That stuff's no fun. You guys want to see a Ranger check, but the problem is Ranger's not there. So we can do a Ranger check, but Ranger is sitting over by my wife and her friends. They're over to the left. So Ranger is not there right now. He has left the building. Well, he hasn't left the building, but he's left the little area that he's at. All right. Well, we hit 3 hours, guys. So here's what we'll do. We will go raid out. For people that made it on the YouTube side and hung out, I appreciate you guys coming by. We talked about a lot of Linux systems administration stuff. Tawny got here right at the end. Tawny, you missed it, man. We kind of blew up over on the YouTube side of things. Actually, just earlier today, we hit 100,000 views on YouTube, which is pretty wild. 100,000 total views across, well, really only like 3 videos, but one video is still kind of blowing up even now. Yeah, it's wild. It got me, like, in 2.5 weeks, it put me in, like, their partner program. So, I don't know. It's funny. When it started, I went to Mexico. So I was like, watching it slowly cool off, and I was telling the wife, it's like I could have been a big YouTube star. I don't care about any of that crap. Most of you guys that know me know I don't care about that stuff. If I could find 10 people that wanted to go do more Linux, that would be the goal of any of these streams, right? Get you guys in there, get you guys interested in doing this stuff. You can do it, right? Which video is blowing up? It's called I'll pull it up for you guys. It's called it's actually from the other day. Beginner to expert Linux home lab working on skills to get into systems engineering roles. Let me pull this up real quick. Hold on. Let me see. Oh, on YouTube. This is it right here. Is it right here? Oh, I don't think all I did in this one was it was really long. So it was a really long lab, and all I did from start to finish was go through the book. So I was just working on making sure the book was good. And I don't know, that's all we did. Oh, I think we did some troubleshooting stuff as well at the end. And then we went back into the book. So that was it. Yeah, beginner to expert. But I've been saying beginner to enterprise because, again, I don't think being an expert is all that important. I think being enterprise ready is what's important for a lot of you guys. So, all right. So here's what I'm going to do. I'm going to go pop on to, here's our little intermission. Right? Some of you guys haven't seen our intermission screen ever. And then after our intermission screen, I'll go pop us on our end of stream. And then we'll go find somebody to raid because there's probably something going on there. How many people watched the whole video? It's the watch time is lower. I think we just hit like 4,500 hours of watch time now, so it's not that much. Yeah, you were late. Let's go to our end of stream here. There's our little end of stream thing. End the user. Let me pull this out of the way. But you guys are all welcome to hang out down in the Discord. We've been getting a lot of people in Discord. That's actually how we noticed that something was changing. Was there was like all kinds of people showing up in Discord. So I definitely appreciate you guys hanging out. You guys are all welcome, and we will talk later. Let's go find somebody to raid on the Twitch side. Who's doing stuff on Twitch? We're gonna go hit BlazeBits. Wait, actually, we raided BlazeBits the other day. He's pretty good, but what other stuff's going on? Let's go. I'll raid over to somebody that I kind of like. You guys might like this too, although he's a gamer. What he does is he plays tournaments of this game called Mechabellum. So if you guys have ever seen Mechabellum, it's a pretty fun little game. We'll go raid over to him to see what's going on. And I appreciate you guys coming by. On the YouTube side, I guess you just have to go find us down in the Discord world and hang out with us down there. That's funny. I actually am a Linux professor at a college. So, all right, take care, guys.